those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. All right, looks like we are live. Everybody, I want to say thank you for your patience. As I kind of predicted, Marshall here, he is on Central Time. So for him, it would be 9. For me, it's 10. But we're all good. We're all good. So we've got a good audience. Marshall, thanks for being here. We've also got the referee. Praise I am, just to make sure things don't get crazy and out of hand. Just kidding, Marshall. I'm sure we're going to be fine. You're cordial, respectful. I'm looking forward to this. And why don't we?
I just wanted to point out that your reminder for your YouTube video just popped up on my phone. So I don't know if you set the time wrong on it or if that's a YouTube thing being screwy.
You know what? Based on some of the comments, there could be. There could have been something weird going on. I did have it for 9, and then once it was like 9:20ish, and we were wondering what's going on, I did switch it to 10. So you would get a new reminder, but since you didn't get the original reminder, then that's kind of suspicious. So either way, we're here now. This should be fun. I'm going to go over the format real quick, Marshall, and then I want you to give just an introduction, since it's your first time on the channel, into who you are, what's going on maybe at your channel. So before that, I'll go over the format. We're not going to be crazy strict with this, but what we have for the audience sake, we have 12 to 14-minute opening statements. As in, at the 12-minute mark, praise our moderator. He's going to give a 2-minute warning to wrap up our thoughts and points. Then we're going to have an 8-minute equally timed rebuttal, 8 from myself and then 8 from Marshall. And then a second 8-minute equally timed rebuttal, 8 from myself, 8 from Marshall. Then a 30-minute easygoing, cordial, free-flowing dialogue pertaining to the points and topics brought up in the first portion of the debate. Okay, and we're going to try and keep it as equally timed as possible with no over-talking, of course. And then we're going to end it with a 5-minute closing statement, and then we're going to get you guys involved. We're going to have a roughly 20 or 25-minute audience Q&A. So please tag Praise I Am with your questions. He is the ref for the evening. That being said, Praise, thanks for being here. A few words from you, brother.
My pleasure, man. I'm looking forward to this dialogue between you two. It should be a good one.
I appreciate it. And before I hand it to Marshall for a brief introduction, super chats coming in from Steadfast and Easy. I appreciate it. God bless you as well. So we got a great chat. And once, like I said, please tag Praise with your questions. I won't be watching the chat, so I will miss them because Marshall and I will be busy having our discussion. So that being said, Mary says, you guys look like long lost brothers. So could be, Marshall.
I did notice that we look similar.
Same glasses, same hair. I'm looking in the
mirror. same youthful smile, same youthful skin.
We're both actually 50, but we look like we're whatever.
Wait, how old are you? No, how old are you really?
Not 50. I'm 32. So maybe 33. I'm forgetting.
Yeah, I just turned 30.
Okay, so there you go. I guess this is the atheist version of SFT. So this is going to be a lot of fun. We've all got, that version of us. Praise. I'm not sure if you've met your atheist version yet. But,
so are you saying I'm your evil twin?
Or maybe I'm the evil twin to you. I guess it's subjective. So Praise. A few words from you, brother.
So we'll just try to have no over talking and none of that stuff, and it should be a clean debate.
That a boy. Praise. That's why we pay you the big bucks for those epic moderator speeches. So Marshall, a few words from you in terms of introduction, who you are, what's going on, and then like we said before we went live, I can start if you'd like.
All right. Well, it's good to meet you, Praise. I don't know if we've talked before. I'm not a scientist. I don't hold any degrees in anything. I don't work as a scientist. I'm just somebody who really likes learning about this kind of stuff. I did take some classes at university in ecology and biology, and but I'm not a professional by any means. I really just got into this whole thing just from watching modern day debates, and somebody was supposed to be debating Nephilim free on evolution, and they didn't show up. So James put in the chat that he wanted somebody to debate, and so I did. So that's on modern day debates, and if you want to check that out, I'm gonna upload it to my channel too, which is just Marshall, or I guess we can probably put a link into it. I don't really have that much content yet. I'm hoping to eventually do more. No, I'm just really passionate about the theory of evolution and biology and ecology and cladistics and that sort of thing. And I am an atheist, but I don't. This discussion we won't really get into that too much. I accepted the theory of evolution when I was still a Christian, so I don't think my religious views really play a big part in this. I'm not really going to try to talk too much against theistic evolution or try to push for naturalism in this debate. I'm mainly just going to focus on common ancestry. I don't think the two are like conflicting, but that's a whole other debate as well. And appreciate you standing for having me on here.
Awesome. I appreciate that introduction, Marshall. In terms of my introduction, obviously people know who I am. This is definitely a fun topic, the topic of ancestry, universal or separate ancestry. I like this topic, one of my favorite topics, because it does focus on the bigger picture of our origins. And there should be lots of great topics and points to discuss. I've written a few books on the topic. Some of them are behind me: Independent Origin, Special Creation, Why Human Evolution is False. And that being said, I'm excited for this one. So I think we'll just kind of get right into it. Praise. I'm going to share my screen here and get my PowerPoint going. So don't start the timer just yet, my good man. Let me know when you can see it. Praise looks good.
Yep, it looks good to go.
Okay, so I guess you can start the timer right now. So tonight we are debating origins. More specifically, we are debating universal or separate ancestry. Is all life related through common ancestry? For universal ancestry to be refuted, all we need is one example of independent origins. We have this evidence specifically with humans. The Bible tells us that in the beginning, God created Adam and Eve separate from all other forms of life. The scientific data strongly corroborates the Bible's account of human origins. Let us start with the mitochondrial DNA. Using mitochondrial DNA, we can trace migration patterns, we can determine ancestry, and we can answer some remarkably interesting questions pertaining to our origins. Firstly, mitochondrial DNA is only inherited from the mother's side, and we know that the majority of DNA differences in the mitochondrial DNA have to be due to mutation. One thing we can trace is time. When did these DNA differences arise? Are the number of DNA differences in the mitochondrial DNA of humans more consistent with universal common ancestry or separate ancestry? When we use the empirical method to measure the rate as to which the DNA changes in this compartment, we find that the rate is fast, much faster than the evolutionary community have ever predicted, 20 times higher than the expected by the evolutionary theory. The mutation rate in the mitochondrial DNA demonstrates that the mother of us all, Eve, lived just thousands of years ago. This data both confirms separate ancestry and refutes universal ancestry. We literally know Eve. There are far too few DNA differences in the world. Evolutionists attempt to put mitochondrial Eve hundreds of thousands of years ago, and that is not what we find. We have scientific evidence confirming the biblical Eve, and the evolutionists have been incapable of refuting this data. Mitochondrial trees grow in branching-like patterns, as you can see here on the screen. We can literally reverse the clock back to the point where we find Eve. We know Eve would have had children, and her children would have had children. And every time a child is born, there is then a chance that child would have a mutation. A mutation is a copying error. Okay, the existence of mutations alone refutes universal ancestry, as they put what? They put shelf lives on genomes. And we will touch on that a little bit later. Now, every time a mutation happens, the result would be a new branch on the family tree. And over time, the family tree gains more and more branches due to these copying errors. We can then back this process up to where we eventually find who? The woman of whom we have all descended from. Eve. I also want to point out the fact that we can count the number of mutations found in people today. All we really find is about 20 to 30 mutations that separate most people in the world today from our Eve ancestor. It is extremely easy to account for the number of DNA differences in the mitochondrial DNA if we start from Eve just 6,000 years ago. On this phylogenetic tree here, we do not see hundreds of thousands of generations. We only see a few generations, as we only see a few mutations. We see a starburst pattern that reflects the biblical model of ancestry. One woman, few mutations, a fast mutation rate, and an expected pattern all refute universal ancestry and confirm independent origins. Now, the rescue devices that the evolutionists put forth pertaining to the phylogenetic rate, coalescence, genetic diversity in Africa, they've all failed for a number of reasons that we can certainly get into if Marshall brings up those arguments. Now, moving on to the Y chromosome. We also know the Y chromosome has extremely low variation. Every single male Y chromosome on the planet is nearly identical. The Y chromosome is also fast, picks up about one mutation every generation. There are only a few hundred mutations separating people worldwide, and our last Y chromosomal ancestor, being Noah, existed just 4,500 years ago. This is all inconsistent with the universal ancestry model. Now, Dr. Robert Carter here took all the Y chromosomes and made a Y chromosome family tree. What we see visually on screen is an explosion from a center point, okay? There's my mouse. And this is an explosion essentially from Noah, the last Y chromosomal ancestor of us all. This is basically all a reflection of DNA differences, a reflection of mutations over time. This reflects far too few mutations if deep time evolutionary history were true. Notice this is exactly what we found with what? With the mitochondrial DNA, the other uniparentally inherited DNA compartment. We're not looking at, once again, tens of thousands of mutations here. We're looking at just a few hundred mutations, and therefore just a few generations, as would be expected if the Bible's account of independent origins were true. This data did not have to be true, and yet it is. Evolutionists are constantly having to retrofit the data into their evolutionary story. They did not predict what? Low genetic diversity in humans today. They did not predict the one Y chromosomal line. They did not predict the one mitochondrial DNA line, the three major mitochondrial DNA haplogroups, all of this consistent with the biblical model of ancestry. Now, one last thing to consider is the fact that, have a look at some of these branches, okay? Some of these branches indicate that some people can actually pick up more mutations in the exact same amount of time. This breaks the assumptions behind the evolutionary molecular clock. Evolutionists cannot now look at the branch length and conclude a deep time evolution. The pattern and the overall data confirm separate ancestry. Okay, the mitochondrial DNA humans, as we know, is nothing like the chimpanzee mitochondrial DNA. But we also have the Y chromosome that is what? Incredibly different between humans and chimpanzees, as you can see here, remarkably divergent in structure and gene content. When we consider overall architecture, gene content, and size differences, guess what? Our Y chromosome is less than 35% dissimilar to the chimpanzee Y chromosome. The Y chromosome is non-recombining DNA as we know it. It should be relatively stable. And yet we see a highly divergent chromosome. How does Marshall explain this massive problem for his model of ancestry? I'd like to know that. Now, we're only minutes into this debate, and we've already got conclusive evidence that humans are not related to chimpanzees. Humans were created separate from all other forms of life. Now, another amazing line of evidence for separate ancestry that I'd love to see an answer to from Marshall, maybe in his opening or his rebuttal, can be found in human chromosomes, okay? Human chromosomes are made up of relatively large linkage blocks, and analyses of these original text strings tells us that the genome is young. Why? Because the genome has only been partially scrambled, okay? Crossovers in gene conversions should scramble all linkage blocks quite quickly in an evolutionary time frame. This is actually a big problem for evolutionary theory. How does Marshall explain this data? Now, moving on to abiogenesis. Due to the epic failure of abiogenesis and origin of life research, Marshall unfortunately must assume life evolved somehow in the first place and then start with changes in allele frequencies and populations over time. He wants life to already be there so he can argue for evolution. Unfortunately for him, he fails at the start of the race. If runners died right before the race started, there would be no race to discuss. When we look at the modern scientific data, we see a reflection of the Bible's account of origins. Everything must have started very good right from the beginning. The incredibly complex information storage system of life could not have been built up from inadequacy to precision. If we did not have a highly functioning decoding system, the entire system would come crashing down. Origin of life research has been a massive, massive failure and faces numerous unsolvable chicken and egg problems. Also, evolutionists have no way to introduce what? Introduce functional information into the first life. How do you introduce functional information into random chemicals? Even if you manage to get the necessary building blocks for life, how is information introduced? This is a major problem for those who want to hold to a naturalistic origin of life. Okay, for example, if I were to spill ink on a piece of paper, I would not at the same time introduce information. So therefore, a book is more than just ink on paper. A book contains specified information. Now, I want to point out real quick, because this is so important, that recent data has also confirmed genetic boundaries in species, okay? The data suggests over 90% of all species today have originated at the same time. This is all perfectly consistent with the biblical model of ancestry and vastly inconsistent with universal ancestry. Okay, winding down here. Evolutionists have assumed lots of evolutionary leftovers, junk DNA, and genomic fossils. Essentially, they have assumed evidence that reflects millions of years of unguided and unintelligent evolutionary change. We as biblical creationists would expect genomes of treasure, not genomes of junk. We would predict function, while evolutionists mostly predict non-function. And yet, what do we see? Paper after paper. The evolutionists love when I say that. Paper after paper demonstrating the validity of these expectations and predictions. Praise, how much time do I have, brother?
You have 3 minutes.
Perfect. So, paper after paper, regulatory activities of transposable elements, intronic ALUs influence alternative splicing. Scientists identify new beneficial function of endogenous retroviruses in immune response. Redundancy of the genetic code enables what? Translational pausing. It's amazing what we're finding here. You cannot be an atheist, at least an honest atheist, in 2021, okay? We have preliminary evidence for genome-wide functionality. With that being said, we can also safely predict, as you can see here, that much of the genome is involved in embryological development. We have windows of development that consist of incredible growth. The trajectory of discovery strongly favors biblical creation and refutes universal common ancestry. The entire junk DNA paradigm has been overturned, including many of the so-called greatest lines of evidence for universal ancestry. For example, we know that pseudogenes, endogenous retroviruses, ALU sequences, and other types of genomic fossils, so-called genomic fossils, are highly what? Highly functional. They're highly active and necessary to sustain healthy life processes in the cell. Even the chromosome 2 fusion has been completely overturned. We have amazing evidence in the uniparentally inherited DNA compartments, as we have covered earlier, for separate ancestry. And as we can see now, we have more amazing evidence for separate ancestry in the nuclear DNA compartment. Okay, we also have this entire additional layer of complexity and functional information that evolutionary mechanisms cannot account for. As you can see here, the epigenome controls how genes make the physical parts of our cells. And this extra layer of amazing information helps turn genes on and off and not actually change the genetic code itself. That's not going to take your fish to fishermen. That's not going to take your pond scum to people. But this is exactly what we'd expect from a created heterozygosity hypothesis and starting point. Okay, now all our genes are not turned on at the same time. This would not be good.
2-minute warning.
Thank you. These are non-random changes. Good design means we have to have some type of control. A type of control that makes sure we have the right things being turned on and the right things being turned off. We have millions and millions of genetic switches in our DNA just waiting to be turned on or off via environment. This is all what? Forward thinking, which points us back to the what? The forward thinker. How do evolutionary processes design that which requires forward thinking? Will Marshall actually propose that evolutionary mechanisms have a mind? What about these orphan genes that are sequences of DNA that code for proteins, but they have no what? Apparent relatives. Exactly what we would expect. Given the special creation model, given separate ancestry, how does Marshall explain the existence of these taxonomically restricted and essential genes? And this is going to be the last portion here for my last minute and a half. What about mutations? We talked about mutations now about 10 or 12 minutes ago. And from one generation to the next, many mutations are passed on, okay? Roughly 100 new mutations per person per generation. We are consistently more mutant than our parents. As a matter of fact, we are multiply mutant, which is why selection is limited. This is 100 typographical errors every generation that our parents did not have. Natural selection must remove or filter out these mutations or else we will go extinct. Most mutations are nearly neutral and only slightly deleterious. They're only slightly harmful to the point where they do not really affect reproduction. Selection cannot see these, which means species are going downhill. Remember, we talked about shelf lives at the beginning of this opening statement? And Marshall does not have millions of years of evolutionary advancement. We see a perfect biological decay curve that matches the biblical model of longer lives closer to the creation. When we actually plot this out and look at the account in Genesis, here we go. This data has almost no chance at being coincidence. This is an amazing correlation between what we know about mutation accumulation, genetic degeneration, I'm done in 10 seconds here, praise, and biblical longevity. It makes no sense that the biblical authors would ever make this up. Also, fabricating this biological decay curve would require exceptional knowledge in statistics and mathematics. The last thing I'll say here, the systematic degeneration of man as documented in the Bible is extremely consistent with genetic entropy and deleterious mutation accumulation. The Genesis biological decay curve reflects real biology and helps confirm separate ancestry and refute universal ancestry. I yield.
Awesome. Thank you for your opening, SFT. So we're going to hand it over to Marshall here. We're going to be lenient. They're going to have extra time if you need extra time, Marshall. So whenever you're ready, I'll start the timer. You have around 14, 15 minutes, whatever, around there in that time.
Okay. Well, I guess I'm ready to start. Yeah. So I really need to brush up more on my genetics. Yeah, I know Standing is really strong on that and wants to really get into that. I don't know if I'd be the best person to refute a lot of that. I guess let me start with just explaining how evolutionary theory works and where it came from, and where the idea and about creationism. So, ideas that life evolved, from a simpler, earlier form of life. It goes back to the ancient Greeks. And so and there were many people around the time of Charles Darwin. Once we started realizing that the Earth was much older than we'd ever thought, started coming up with ideas of how life came about. Because that's really the question we're looking at. We can both agree that biodiversity exists. That there are many forms that life comes in. With slight variation within those forms. And so the question is, where did those differences arise, and how? And Charles Darwin realized that he was the first one to propose a mechanism, and it's often misconstrued to think that, well, one type of animal gave birth to a fundamentally different type. If that happened, that would actually go a good ways towards disproving evolution. It actually works on the population level. You have slight variation over time. As populations are separated, they will naturally tend to head in different directions genetically. That's really all evolution is. It's just a descent with modification over time. And so then we can observe this type of thing happening due to natural selection, genetic drift, and that sort of thing. And then if we look backward in time and apply the same methods that we use to trace common ancestry, even among people that would hold up in court, using those exact same methods, we can trace all life back to a common ancestor. The exact details of the tree get a little fuzzy once you get back towards single-celled organisms and such, because you have what's known as horizontal gene transfer, where unrelated species can often swap genetic material with each other. So it does get a little fuzzier the further back in time you go, but the evidence for man having a common descent with the other great apes is overwhelming, both genetically and in the fossil record. Now, because the evidence has become so strong among the scientific community, you won't have these kinds of debates happening in a university. Pretty much I would say every major scientific organization accepts the validity of the evolutionary theory. So what's happened is you have an entire industry that has sprung up of pseudoscientific journals and such as Ancestry and Genesis, where you have to take a statement of faith, and you're only allowed to publish things that comport with the conclusion that they started with, that they've already drawn, and they won't allow any evidence that to the contrary. So any statement of faith on a scientific or so-called scientific organization's part, to me, that's an admission of academic dishonesty. I'm sure Standing will disagree with that. But so for example, I would like to ask, where some of this information came from, if it's from mainstream, university studies, or if it's from, creationist organizations. I know the mainstream ideas that mitochondrial Eve, I believe they say it's about 180,000 years ago, and she wasn't the only person alive at the time. And Y chromosome Adam, it's honestly kind of unfortunate that they chose those names, because he wasn't alive at nearly around the same time either. It was just that if you trace everybody's ancestry back, we all do share a common ancestor with one person, and that one person happened to live roughly 180,000 years ago. I know SFT has some different data for mutation rates and molecular clocks. I would wonder if that's has something to do with not taking into account selective or stabilizing selection. But I just when you're like me, or probably many people in the audience, if you don't really know that much about something, it's generally wise to stick with the scientific consensus, because the scientific consensus is taking into account all the data as a whole. And it's really difficult as a layman to actually look at the data. And even if you do look at the data, it's hard to understand it if you don't have the proper background in math and statistics. So, like I said, I don't really know that much about genetics. I just know that, mainstream genetics supports scientific or common ancestry. But then if you look at morphology, phylogenetic morphologies, you can see a clearly nested pattern of traits among a twin nested hierarchy. That is, you can trace out a cladogram, a tree, between a common ancestor and the descendants, and you can look and see what shared characteristics they have, and many times we can even see where genetically they lost those traits. For example, we know which genes we can switch on in a chicken to make it have teeth. So that shows the exact location where the loss of teeth occurred. And then if you look at, for example, whales nest within the artiodactyl group. Artiodactyls are even-toed ungulates, such as cattle, hippopotamus, sheep, those sorts of things. Now, it's often said that, well, that the similarities in DNA indicate a common design. Well, I can't think of any reason that a designer would need to give a whale common design elements from hoofed animals rather than giving them design elements borrowed from another aquatic animal. And that's the sort of thing I would expect to see if special creation was the explanation. You would expect to see traits from different animals used in different groups. You wouldn't see traits reserved for certain groups and then modified over time. And there's a whole study of baraminology, is what they call it, where basically it's trying to find the different created kinds. Because early creationists or early Christians, they saw that species are different, and it was assumed that species were always like that. But as more data about speciation came in, and then also there's a question of how many animals can you fit on an ark? In order to try to solve those problems, they do accept some common ancestry. So many will put that at the family level, but you really don't see any clear distinction on where to draw these lines in kinds, and that's why it often changes. I would posit that any clear criteria you can give for what a kind is, you could also apply that to chimpanzees and humans and conclude that chimpanzees and humans are the same kind. We also have a well-documented fossil record of intermediate species between humans and chimpanzees, for many other species, but with humans, we know that Australopithecus was bipedal. They had smaller brains than us. If you saw an Australopithecus, you would say, well, is that a chimp? Is it just walking upright? And then you have a whole line of fossils going up to Homo habilis, Ardipithecus, where you see an increase in brain size and decreases in things like tooth size, and increases in body size until you get to Homo erectus, where they still have the heavy brow ridges, slightly smaller brains than us, but built pretty much like us, on up to Neanderthals, and which are cousins of ours and not directly related. There are still many questions within the tree of where exactly to put everything, but there are many species that we can confidently place as somewhere on the tree between us and chimpanzees. Even Carolus Linnaeus, he couldn't, when he developed his system of taxonomy, he basically said that he arbitrarily decided to not include humans as a species among the great apes, for fear of the backlash from the clergy. Sorry, guys. I've had a little bit of a headache today. So, where was it? It's yeah. So I would posit that if universal common ancestry, or if special creation was true, there should be clear delineation where we can draw lines between what a kind is. For example, if orphan genes are clear evidence of a lack of common ancestry, then it should be relatively simple to just look and see, okay, which species have no orphan genes between each other and which ones don't. But you won't find that clear distinction. SFT also brought up abiogenesis. That's one field where I'll admit that the evidence is not as strong as with evolution. And essentially, it is one of the gaps that God can still hide in. If you want to posit that a God made the first life and kicked it all off, well, I don't think that would be precluded by what we know yet. But we are learning more and more in that field, and essentially, both explanations require abiogenesis. The special creation just requires many separate events of abiogenesis started by a God, but it would still be abiogenesis nonetheless. But we're making great progress in that field. But we may never know exactly how it started.
2-minute warning.
Okay. So anyway, I think I'm kind of rambling now. We'll probably get into more productive dialogue in the open discussion.
Awesome. Thank you for your opening, Marshall. We're going to transition now into the rebuttal session. And we have 2 8-minute periods, so I'll try to give you guys like a minute warning or something around there to let you guys know I have about a minute to go. And I'll say wrap it up, whatever. Just try to wrap it up within a good time frame. But whenever you're ready, SFT, I'll start the timer.
Actually, before you start the timer, Praise, it sounds like your mic has devolved. And is a black hole. It's kind of crackly, but that's fine. Just to let you know. But I did catch what you said there. So, yeah, start the timer in 1 second. Okay. So I got a ton of notes here. Thank you for that opening statement, Marshall. And Praise, let me know if my audio is coming in okay. But Marshall talked a lot. He brought up a lot of good topics there that a lot of them I think we'll save for the discussion portion. But what I will say is natural selection, genetic drift, changes in allele frequencies, and all these mechanisms that Marshall pointed to in his opening are mostly fine-tuning. Okay, they keep a species as strong as they can be, especially with natural selection. But when it comes to mutations, which are supposed to be the driving force behind large-scale evolution, they are essentially degrading to the functionality of organisms. Okay. Now, evolutionists assume common descent to prove common descent, as we have seen there with Marshall's arguments pertaining to phylogenetics and nested hierarchies, okay? Marshall said he was not up to date on genetics, and that's fine. But then he looked to genetics to demonstrate his belief that fish and banana plants are related, which is his burden of proof today. As I pointed out in my opening statement, I only need to provide one solid case of independent origins to absolutely destroy what? Universal common ancestry. Because universal common ancestry says that whales, humans, and strawberries are all related through common ancestry. And I spent roughly 14 minutes demonstrating that humans are separate from all other forms of life through a wide variety of ways that we can touch on later in the discussion portion as well. Or he can attempt to refute in his rebuttal portion. Okay, so he also looked to arguments for majority. That's a logical fallacy. Most scientists actually grew up evolutionists, and they've never once read a creationist technical paper. And this is why they cannot compete with creationists on testable predictions. Okay, the gold standard of science is to make testable predictions. And we are the ones making these predictions in all types of fields. Now, specifically to answer the question of ancestry, which is the topic of tonight's discussion, we must look to what? Genetics. As we know, fossils, bones, geography, okay, these things are not inherited sperm and egg. Genetics, genes, traits are what are inherited sperm and egg. And Marshall, he said that mitochondrial Eve was dated hundreds of thousands of years ago, and also said the same thing about Adam. Well, the problem is I refuted that in my opening using empirical data from phylogenetic trees pertaining to the Y chromosome and the mitochondrial DNA, and that we know the Y chromosome mitochondrial DNA mutate way too fast, and there are far too few DNA differences. Plus, the Y chromosome and mitochondrial DNA have incredibly low variation that cannot be accounted for in deep time evolution. Okay, why is every single Y chromosome on this planet, when it comes to humans, nearly identical? And yet the Y chromosome between humans and chimpanzees is less than 35% dissimilar. You know, I'd like to see an answer to that if humans really are related to chimpanzees. Now, Marshall could argue all day that dogs and cats are related, and because they are carnivores and also mammals, they are then related to bears. And since bears are also carnivores and in many ways share numerous features in terms of anatomy, morphology, physiology, and genetics with both dogs and cats, this isn't going to help Marshall's burden of proof tonight because, as I pointed out, he needs to demonstrate that dogs, cats, bears, and banana plants are related. And this has not been done. Now, to make it even worse for Marshall, and I'm looking at my notes here based on everything you say, talked about the fossil record. So this is even worse for Marshall because what is called the Cambrian explosion, okay, when we go back far into the fossil record, well, we reach the Cambrian explosion where we have all this phyla suddenly appear out of nowhere. We have jellyfish, coral, trilobites, and these are all greatly different organisms. We have these different body types, different body plans, all highly complex structures, and yet what we see is no evidence for this assumed evolution. This is all the opposite of what Darwin expected. If we have a phylum level event like the Cambrian explosion, there must have been astronomical numbers of evolutionary experiments in order to evolve such amazing complexity and features. The evidence isn't there for universal ancestry. What we see is evidence for special creation. The evidence does not support his position. And the fossil record does not help Marshall, and obviously neither does genetics. So we see boundaries in genetics. I presented the genetic boundary study, okay, that demonstrated that 90% of all species arose at the same time. So yes, we do see a line in kinds. We see evidence in genetics and evidence in the fossil record when it comes to boundaries. And I'll get to the fossil record a little bit later when it comes to baraminology, but Marshall talked a lot about morphology, phylogenetic systematics, okay, which involves a huge number of assumptions that we'll get into, a huge number of contradictions with the phylogenetic tree. A couple are incomplete lineage sorting. Depending on what gene you're looking at, you can derive greatly different and contradictory trees. Okay, we've also got convergent evolution and loss of traits evolution. I'll get a little bit more into those later, but I really want to get into his arguments pertaining to nested hierarchies, as well as more so into phylogenetics, because when it comes to hierarchies, looking at these trees, when it comes to what I'm going to do actually is share screen here real quick. Praise, if you can pause my timer actually, because I want to put it up on screen. Okay. Okay, here we go. You can start the timer now. So when it comes to phylogenetic systematics and nested hierarchies, okay, as you can see here, cladistics, cladograms only demonstrate a nested hierarchy of biological characters. They tell us nothing about what produced the pattern. And that's the problem, is we as creationists would predict that we're going to share more in terms of morphology, anatomy, physiology, and genetics with the chimpanzee than we would with a fish or a banana plant. We would both predict the existence of a nested hierarchy. But what produced that pattern is obviously the question. Okay, we've got incomplete lineage sorting here, as I pointed out, which is a major problem that shows these contradictory phylogenetic trees depending on what gene you look at. Okay. There's a few studies here that you can look into as well. And I want to point out that looking to fossils as evidence for universal common ancestry is actually low quality and low confidence science, because I really want to point this out. This is from the Scientific Approach to Evolution, which I highly recommend, in that the fossil record can be very, very deceiving in answering this question of ancestry. Okay, so I want to point out here, one of the world's foremost paleontologists, Jack Horner, presented a brilliant TED Talk in November 2011 entitled, "Where are the Baby Dinosaurs?" He presented numerous impressive dinosaur finds, each classified as a separate species and bearing the name selected by its discoverer. Okay. He then pondered why we never find baby versions of the name dinosaurs. By cutting into the skull bones, thanks, Praise, and performing microscopic analysis of bone structure, he was able to estimate the maturity of each animal at death. As a result, listen to this, many separate dinosaur species turned out to be different levels of maturity at the same dinosaur species. Infants, adolescents, and adults of the same dinosaur species had been incorrectly classified as separate species. Horner explained that this occurred because why? Scientists have egos, and scientists like to name things. Okay, so oftentimes any little variation that you find in the fossil record, they're going to name a new species. You never remember the 10th guy who found a Tyrannosaurus Rex. You remember the first guy. Okay, so any little variation they want their claim to fame, they're going to claim as a new species. Now, here's the problem is we know there exists oftentimes more variation within the same species today than across species. And therefore, when you're looking at a bone where we don't have the genetics, it's going to be difficult to be able to tell what is the result of convergent evolution or homology. That's why genetics is key to answer this question of ancestry and not fossils. I yield.
Thank you for your rebuttal, SFT. And now we're going to hand it off to Marshall for his 8-minute rebuttal, whenever you're ready.
Okay, so am I rebutting his opening statement? Or
yeah, or whatever you want to rebut, yeah.
Okay. I'm sorry, guys. I'm just not really feeling good tonight. So let's see. I want to point out that pointing out a scientific consensus is not an argumentum ad populum or an argument from authority. It is pointing out the preponderance of evidence is on one side, that the people who are actually doing the work in this field in accredited universities, the science points in one direction. I don't think that's an appeal to a false authority or an argumentum ad populum. I will agree that there's limitations to what we can find from the fossil record, and is it possible that everything was created to look like it shares a common ancestor? Sure, but when you look at the way things are nested, it doesn't, to me, make sense from a separate creation point of view, because you have many species that fill completely unrelated niches and yet are nested within another group of species, and so it doesn't really make sense to me from a common design perspective. And Standing will admit that many of the species that we find do share a common origin. For example, donkeys and horses, or maybe all felids. I'm not sure exactly where he would want to draw the line. But then if you accept that all felids share a common ancestor, we can ask, what about civets and mongooses and so on, and then we can apply the same kind of whatever methodology you arrive at for a common ancestor between other species. You can also apply it to chimps and humans. I don't know the specific studies that he's pointed out, but the reason I go to the scientific consensus is because if these are actual rigorous studies, they should be able to publish them in a peer-reviewed scientific journal that's not just a creationist journal, and then that would become part of the scientific consensus. But since it's not, I'm going to go with the scientific consensus on it as far as mutation rates and dating of mitochondrial leave and so on. When you talk about like completely disparate species being related, that's kind of to me, that's kind of deliberately looking at the far ends of the spectrum to try to make it seem less credible. Whereas if you dial in on the closely related species, the differences become less obvious. And the Cambrian explosion is no problem for evolutionary theory. We know that's when many more like, for example, hard shells evolved then. Things that are much more likely to fossilize evolved at that time. And also, many times you have, when something evolves, it triggers other things to evolve. It's sort of this evolutionary arms race. So it's an explosion, but it's not like all of a sudden one day there was nothing, and then the next day every type of modern life we have now. It's just that many of the broad categories we can trace them back to that era, but we have found Precambrian fossils, and it's not like it's all of a sudden just one explosion. This was an event that took place over many, I think it was 300 million years or so. So it's evolutionary science has no problem explaining the Cambrian explosion, and it really doesn't do anything to bolster a creationist point of view. I yield my time.
Okay. Thank you for your rebuttal there. So we'll go now to the open discussion for 30 minutes.
No praise. If you look in the side chat, we've got our second 8-minute rebuttal now.
Oh, I'm sorry about that. So yeah, it's your second 8-minute. Okay, so go ahead, SF2, when you're ready to go.
Awesome. Yeah. Let me see. I got so many notes here. So you can start the clock now. So one thing I wanted to point out before anything is that Marshall did, and I respect the fact that he admitted to abiogenesis currently being an unsolved problem. I purport it will never be solved, given, for one, the arguments that I put forth in my opening, but also the number of chicken and egg problems that abound. And this is precisely why the design diversity hypothesis is stronger, because it makes accurate predictions on function. If God would have front-loaded Adam and Eve, which would apply universally across the biblical kinds with pre-existing functional DNA differences and DNA elements that would allow for adaptation, change, variation, okay, then obviously we would predict that the majority of the genome and DNA elements, such as endogenous retroviruses, pseudogenes, so-called ALU sequences, okay, are functional and essential, and yet that's what we find. But the evolutionists don't want to make predictions on DNA function because they need to maintain a genome of junk in order to absorb the majority of those deleterious mutations that are accumulating from generation to generation, making them absolutely neutral, strictly neutral, because the more functional the genome is, the faster genomes are degenerating due to these new mutations pouring into the genetics of living organisms generation after generation. Okay, that puts shelf lives on genomes. So the evolutionists are stuck between a rock and a hard place. Now, Marshall kept looking to nesting patterns. So I want to deal with that in more detail. And I do have some slides that I'll pull up actually in 1 second. But when it comes to these groups within groups patterns, okay, that evolutionists like Marshall point to as evidence for descent with modification, well, the problem for the evolutionists is, for one, the contradictions to the hierarchical patterns, which we'll get into in a bit. We kind of talked about it with convergent evolution and incomplete lineage sorting. But the problem is, it's a line of evidence that is agnostic to the debate. It would be like me pointing to the fact that the sky is blue as a line of evidence for creation. No, evolution can also explain why the sky is blue. Both models can explain homology, nested hierarchies, mosaic creatures, okay? Because the classification of life can actually be compared to the classification of modes of transportation on how different companies manufacture cars based on their similarities, which actually form hierarchies. Now, here's the thing. Our model would suggest that we were created in the image of God, and therefore, because oftentimes these evolutionists like Marshall misrepresent what we're saying about cars. They'll say, oh, cars don't reproduce, or what are you going to look at to classify cars and put them into these categories? No, the problem is they're not understanding our model that says, since we were created in the image of God, we should get a sense for how God may have designed the biological world by the way we design things. So, unfortunately for the evolutionists, we design in hierarchical patterns. Think about it. All sedans are incredibly similar to each other, right? Sedans are much more similar to each other than what? Well, than they are to SUVs. And sedans and SUVs are more similar to each other than they are to tractors. Okay, and yet we can group sedans, SUVs, and tractors because they share enough similarities where we can group them together as land vehicles, which then sets them apart from what? Boats and airplanes. Okay, this is the groups within groups patterns that emerges when we classify modes of transportation. And nested hierarchical patterns are just simply a hallmark of design and reflective of God's hierarchical nature. Okay, and it just so turns out that we also design in these types of patterns. Plus, it makes no sense. It goes back to the whole phylogeny challenge. Okay, well, why couldn't God create kinds of creatures in the beginning that are different from us? Okay, like a human and a fish versus a human and a chimpanzee. Obviously, by definition, God's going to create some creatures with more similarities with each other and other creatures that have less similarities with each other. So evolutionists miss the bigger picture. Yes, we find hierarchies in all of the biological world, including humans and apes. Okay, but the fact is, these hierarchies are reflective of design. Homology is reflective of design as human engineers build in homologous patterns. And before I forget, I want to get to convergent evolution because this is a major problem for his phylogenetic trees, because when you see the evolutionists invoke convergent evolution, okay, what they're doing are implicitly acknowledging a biological part or feature that does not follow the what? The expected taxonomy. And yet they want to look to taxonomy. And yet there's so many contradictions. Now, these inconsistencies, okay, in the phylogenetic tree are always explained away by these types of things like convergent evolution. Because remember, you can find paper after paper where the evolutionists admit that they first assume that there's a tree, they assume there's ancestry, and then they force fit the data into their diagrams, into their work. And that means it's not science, it's not falsifiable. And for anybody wondering, all convergent evolution is, it's a rescue device, but it's the appearance of the same trait or character in independent lineages. And it's an invention in order to hang on to their phylogenetic tree instead of admitting that it's not quite as consistent as they'd like to make it out to be. Now I'm going to share a screen here real quick. Praise, if you could just pause my timer. And okay, so right here. So as you can see here, he also looked to transitional forms. And so here's what I'm saying about the nested hierarchies, okay? You can see that these modes of transportation, modes of transportation fit these hierarchies. And even just looking at their phylogenetic trees, I mean, is it really a surprise that humans are closer to chimpanzees than humans would be to a lizard or a fish? You know, this is why I say both models predict the data. But we would predict that these hierarchies are there by design, and therefore we would predict function. And that's why what we're finding is function, and evolutionists are not matching up to the data, okay? Like I said, homology, yeah, we see thousands and thousands of similarities in all different types of modes of transportation, and yet we know this is due to design. Even so-called transitional forms, we see vehicles such as this, you know, military assault vehicles, amphibious military assault vehicles, I should say, that seem to blend the features of different types of vehicles. Same thing we see in your crossover SUVs. Okay, to the evolutionists, this is the perfect example of a transitional form, which is funny. But when it comes to the fossil record in boundaries. I'm looking at my notes here to see how much I can get done, because I want to point to, if I can find it here, the studies that have been done in baraminology, which, let's see. Okay, I've got it in this slideshow. We'll get into the number of species in a bit.
1 minute.
As I know he pointed to that. Okay, so in my last minute here, I'll point out that we have actually determined boundaries in limited ancestry in the fossil record. And using baraminology, as he's pointed to, I'd highly recommend these studies. We found boundaries in Dinosauria, the rhapsids. Okay, so we actually find discontinuities, because when we're looking for these created kinds, what we want to do is find a group that is discontinuous and separate it out from every other group, but yet within it there exists continuity. Okay, and this is exactly what we find. Is we find these boundaries in Dinosauria, and we find strong discontinuities, and not one continuous unbroken chain from one creature to another. And this is based on predictions and expectations of the biblical creation model of ancestry. We see the same thing when it comes to humans, Homo sapiens being separated out from your Australopithecines
Wrap it up.
and your other ape types. So I'll yield there.
Awesome. So that's the end of your second rebuttal. So Marshall, when you're ready, I'll start the timer for your second rebuttal.
Okay, you can go ahead. So you mentioned about how we're always finding functionality. I saw that in your debate with Erica, Gutsick Gibbon, and I felt like she did a pretty good job of refuting that. If you were finding more functionality, that doesn't necessarily entail that everything is going to be functional. If you can look at the proportion of what we've looked at, and then you look at the entire proportion of what's left to look at, I think you can pretty much extrapolate how much function you're going to find later on. And she brought up the studies where they've wiped out large parts of the mouse's genome, and the mice were still able to function just fine. And also with the endogenous retroviruses, she did concede that so many of them do have function, but it's the function is usually secondarily, or our hypothesis is that the function is secondarily involved. And you talk about the sort of idea of genetic entropy, but that hasn't been demonstrated in any rigorous peer-reviewed studies that I know of. And we know in very small populations it can be an issue, and sometimes populations do go extinct because of a buildup of harmful mutations. But if the entire population or doesn't go extinct, the ones that don't die off from that then continue on. It's usually something we see in asexually reproducing species, which don't exactly behave the way sexually reproducing species do. When you have sexually reproducing species, recombination tends to cause these harmful mutations to be accumulated in certain individuals, and those individuals lack fitness, and then they don't reproduce. So there is, we can, really, whether a mutation is harmful or beneficial is really based on just whether it's selected for or not. So a harmful mutation not being selected against is, it actually would be just a neutral mutation. And if it's kind of easy just to think about if this idea that humans have this genetic load that we're going to go extinct from in sometime in the near future or whatever. When you look at the differing generation times, and then compare them to years, if harmful mutations built up in such a way that species go extinct, so quickly, then there would be none of these quickly reproducing species like bacteria or even insects, mice, that sort of thing. If we're building up mutations that fast, they should be building up mutations way faster. So I think that's It's just something that should, it's kind of obvious. Yeah, when you bring up the example of cars, thank you for pointing out that they aren't reproducing the way living things are, but I think it kind of misses the point in that a car from one, from can a car company can take design features from one vehicle and put them in another. If you look at many, like say, I know this was pretty common with like SUVs for a while. You'd have the front end that looked just like a pickup, but then the back end is an SUV. And so you see these sort of chimeral things where the major design features can be shared between different makes or different types. If you're trying to use types as in like the function of the vehicle as the analog for the homology. But we don't really see the same thing in living things. You'll never find a mammal that just grew feathers, for example. And when we do find convergence, convergent evolution is actually more in favor of the evolutionary idea, because we have species that will share fundamental characters, their mode of reproduction and their, and sort of that sort of thing. And yet superficially, they may resemble another group. For example, the thylacine has the reproductive system of a kangaroo, basically. And many other smaller, when you get that looking at it, has many other, features that it shares with marsupials, and yet superficially it looks just like a dog. That's actually, predicted by evolutionary theory, that if you have the same sort of pressures in an environment, they're going to tend towards similar designs, because a certain, design is optimal for that lifestyle. And when you look at biogeography and convergence, then it really starts to look, it's like, well, Australia was full of all kinds of marsupials that, tend to, converge on different things that are, parallel to placental mammals, and yet they're obviously unrelated to the placental mammals. In obviously, each group is unrelated. I mean, like a marsupial mole is not a close relative to a placental mole, and the genetics bears this out as well. And again, if there are these clear delineations between what a kind is, then you would think that all these creationist organizations could agree on exactly where to draw the line between kinds. But it seems like the goalposts get shifted around a lot in that regard. I've even heard some say that maybe whales did adapt from land mammals. And I think like is it the Ark Encounter? Now they show a Hyracotherium as the representative of the horse kind. And so I'm still not seeing where exactly the lines can be drawn, or how we know that, and how we know the line between humans and chimpanzees wouldn't also make them the same kind, using that same criterion. I yield.
Awesome, very good. Appreciate your second rebuttal. Now we're going to move into the open discussion, and there'll be a 30-minute period. But since you just finished, Marshall, I'm going to probably give it to SFT. Is going to start the discussion, if that's all right.
Okay, I just want to point out, I'm fine with going however long you want, but if you want to cut it a little bit short, that would be fine with me too.
Awesome. Praise, if you want to put 25 minutes on the discussion then, and then we'll do 5-minute closing, and then we'll just kind of shorten the Q&A a little bit too, get through a few questions, since we are going on an hour and 10 minutes. So first thing I'll say, there's so many points to say, and I don't want to go. I'm going to make a couple points here based on what you said, and then I'm going to ask you a question, because you pointed to I guess some possible responses that Erica provided, but she actually lacked a response to a lot of these functional DNA elements that evolutionists once assumed were evolutionary leftovers. They assumed genomic fossils because that would be their position, right? The evolutionists assume that the vast majority of DNA differences have been the result of mutations over time. Or when it comes to these ERVs, these endogenous retroviruses, they assume they are the ancient remnants of past viral infections millions of years ago. This is what they predict because they assume a long history of descent with modification. Okay, so that would make sense. While the creationists, we assume created heterozygosity. Heterozygosity just means a state of DNA diversity. Therefore, we would expect a lot of these so-called genomic fossils to actually be functional and essential, put there for a reason. Now, what we find is paper after paper confirming this, okay? Marshall, so my question to you would be, if you think this fits your model or you think there's been a good answer provided, then when we just look to something like an endogenous retroviruses, retroviral promoters in the human genome, we know these ERVs are functional in terms of determining cell types, functional in terms of embryological development, functional in cell stress responses, all of these things that are essential. Okay, here's a paper that shows how they're functional in immune response. How do you explain a non-functional ERV going from non-functional to something incredibly functional in what? The immune system, determining cell types, embryological development. Yeah, how do you explain that according to your model? Marshall, go ahead.
Well, anything that can have an effect on the gene expression, right? Anything, if it enters in such a way that it actually can do something, right? It essentially is acting in a similar way to a mutation. If it just happens to do something and that thing happens to be beneficial, then that organism will have a better chance at surviving. And then sometimes if something evolves to do a function and then it does it better than the previous function, that the previous function that did that same thing may become redundant and no longer be selected for. So I don't think it's a problem to have a percentage of the endogenous retroviruses actually becoming functional.
I appreciate that answer, and I'm going to respond. It looked like that there's a little bit of fuzziness coming from your last response. It was fine, but I'm not sure if something changed in your mic, or maybe it was just me. But what I'll say here, I want to share screen again, and so my question would be then, when it comes to that explanation for, say, functional endogenous retroviruses and functional ALU sequences, so on and so forth, the problem is if you were to have an infection millions of years ago, right? That infection or that viral element is more likely to disrupt genetic information rather than improve it. And yet what we find is clearly an improvement. Now, it'd be my position that these are created units of DNA function rather than the ancient remnants of past viral infections. So in order for your explanation to be empirical, we would have to have empirical evidence to support such a thing, okay? Because mutations, viral infections, they are more likely to break down pre-existing genes, and that's actually what we see with the majority of mutations and these types of changes. But if you want to say that they're making things better and these ERVs are co-opting novel functions, well, do you know of or have a technical paper demonstrating something like a non-functional ERV going from non-functional to functional in the immune responses, embryological development? Because one thing I'll say this, we have data where they've done genetic knockout tests on mice, and you've got this specific class of retrotransposons in the mouse genome that's involved in embryological development. And when they snip it out, when they knock it out, the mouse is developing, but then it suddenly dies because it's dependent on the function of that retrotransposon, that class of retrotransposon. So it's pretty important and pretty beneficial. So do you have, an empirical paper or anything demonstrating that, the validity of that answer, Marshall?
No, I don't have any papers. If somebody wants to give me some recommendations on how to get some better access to scientific papers, I'd be all for it. I haven't, since I'm not in college anymore, I don't really have a way of like even looking up these papers. But I do have an argument against it, or for it. So you said that the vast majority, are disrupt genetic, right? But if it's possible that some can improve it, we know that the way selection works, that there's also, when you look at how vast populations are and have been over time, when you have so many chances, if like let's say like 99% are harmful but 1% are not, well, that 99%, you're just going to end up with maybe a less fit organism that dies out, and then that virus no longer is spread, whereas that 1% that is helpful is going to be more likely to be passed on within the species. So you would actually expect to see a larger percentage of useful viruses being expressed than the percentage that actually if they're helpful, they're going to be more likely to live on. And you do accept that like retroviruses exist, right? That like things we have observed viruses like inserting DNA into DNA. You're not arguing that that's not a thing, right?
Well, my point would be, and there's a bunch of things I want to say there, some points you brought up that I want to touch on. So I always point out that the question when it comes to these retrotransposons is, are these really the ancient remnants of viral infections, or are they created units of DNA function? So we would predict function. And I understand that the evolutionary community is now retrofitting the findings into their story, but I would challenge you to show me a paper prior to the discovery of these essential functions in these classes of retrotransposons where they predicted function. For the most part, the evolutionary community predicts junk and evolutionary leftovers and non-function because these mutations that accumulate, Marshall, over time, okay, and population geneticists who are not evolutionists, and I've got a number of papers to demonstrate this, they acknowledge the problem of nearly neutral mutations and the fact that most are unselectable. So you keep saying that the deleterious mutations can be selected out if they're harmful enough by natural selection, but the problem is natural selection is limited in that it can amplify the best beneficial mutations, okay, Marshall, and it can remove the worst detrimental mutations, right? There are some point mutations that lead to death, lead to a disease that's so significant it leads to death. Just one single point mutation. Sure, natural selection sees that. But the vast majority of them build up like rust on a car or single spelling mistakes in a book the size of an encyclopedia. And this isn't a creationist invention. I could show you some quotes if you'd like to from famous population geneticists where they acknowledge these are unselectable. Selection can't see them, and so they are subject to genetic drift. So selection doesn't work for you, Marshall. And you're saying if 90 or 99% of them are harmful, but then we get the 1% that's beneficial. Well, these numbers have been done in a massive number of simulation experiments where they assumed, okay, let's see if the vast majority of the genome is non-functional. Okay, is that going to help natural selection? Is that going to help stop the degeneration of our species? But what they find is even if the genome is only 10% functional, that's still 10 deleterious mutations accumulating from generation to generation. That's still too much, is what they're finding, and these papers have been published as well. So my question to you then, knowing this, what type of selection then are you going to provide that will remove the I understand you agree that selection will remove the worst deleterious mutations, but what about just the slightly deleterious mutations? How do we get rid of those?
Well, if it's slightly deleterious, that means it's going to have slight selection pressure against it. So it may take longer to be removed, but it will still eventually be removed if it's deleterious enough. And if it's not deleterious enough, then it's just going to become part of the genome of that species. And you have recombination where with sexually selected or sexually reproducing species, they can swap their genome over, and so when you have new genetic information coming in from a different source, well, then you've just swapped off half of your your genetic material. So when I looked into this, they basically said that yes, it is an issue in small populations, and especially asexually reproducing populations, but it's not an issue with a large enough population. And it seems to me that if you had the two of every kind coming off of Noah's Ark, you would expect to see some genetic issues arise pretty quickly in some species there.
If I could address that real quick, because we would start from, well, let me ask you just to make sure that we understand each other's models. How do you, from the evolutionary standpoint, how do you explain the vast majority of genetic variation and DNA differences? What created the variation and DNA differences that we see in species?
Well, I think most of it comes down to mutation, and then there's different forms of selection, genetic drift and natural selection and those sort of things.
Right. Selection and drift are going to act upon the mutation.
Yeah, I do have a question for you when you have a chance.
Yeah, no problem. So I would just say, okay. So since we have limited time, yes, you explained the vast majority of DNA differences, genetic variation as a result of mutations. That's the source of genetic variation. We as creationists, we propose what? Created heterozygosity, that God would have front-loaded the original created kinds, Adam and Eve, with pre-existing functional DNA differences, genetic variation. So if at creation there are no mutations, right? Because inbreeding is a problem. Why? Because it reveals the hidden reservoir of genetic mistakes. If there's no genetic mistakes at creation, then you're not going to have any genetic mistakes to come to the forefront, leading to genetic degeneration. But the evolutionary model, because you guys explain, like you said, the vast majority of genetic variation as being the result of mutations over time, then your bottlenecks that you propose, either 70,000 years ago, 200,000 years ago, those would be damaging, because now you have all these mutations that are in recessive form manifesting, leading to genetic degeneration. And that's why in the fossil record, when it comes to Neanderthal, Erectus, Floresiensis, Naledi, Luzonensis, okay, you name it, what we see is genetic degeneration. We have these small populations that go into isolation, and what we see are founder effects. We find inbreeding, we find genetic degeneration. We don't find forward evolution in the fossil record. This is all consistent with genetic degeneration. So that's why that wouldn't be a problem. And your one thing, and I'll let you get to your question, but I wanted to address what you said, where so you're saying these mutations, these deleterious mutations, build up, and eventually they build up to the point where Mother Nature.
Well, if they're deleterious, they're not going to build up. It'd be the neutral ones that are building up.
But here's the problem, because I think you're missing the point. And I could share screen if you're not up to date on the literature, but we have population geneticists acknowledging the fact that these neutral mutations, Marshall, they're actually effectively neutral. They're slightly deleterious. They're not strictly neutral. They're slightly deleterious, but they're not deleterious enough where selection can see them. So they build up over time and they result in genetic sickness. So the question is, what type of selection removes those? And you said that they would build up enough where eventually they're noticed. Was that your explanation?
Well, they're going to be mixed up with. Like I say, I'm not a geneticist, so I don't understand this entirely. But the explanation that I read was about how when you have recombination, that tends to shift. It mixes things up to where you don't have this buildup occurring when you have new genes coming in.
Okay, fine. I'll deal with that, and then I'll let you get your question. So here's the problem with recombination, why it doesn't work. Okay, is we know that recombination appears mostly between genes rather than between just single nucleotides. Okay, Marshall? So that means, for the most part, within any local genetic sequence, there's mostly no recombination. Now, we do have evidence for what's called gene conversion, which would help break up those DNA differences. But for the most part, we have these blocks of DNA that are essentially immune to recombination. So this is why recombination doesn't work for you, because if we have a massive amount of deleterious mutations mixed in with a few good mutations, and they cannot be separated, that means the deleterious mutations will overwhelm the good mutations, which will lead to degeneration. So if you can't separate those, and this is actually a problem called Muller's ratchet that has been recognized by population geneticists, then recombination isn't going to help you either. It's not going to get rid of those deleterious mutations. So the problem is, and this is the last thing I'll say, and you can give a response. I know you have a question too. I don't want to dominate the questions, but every single person on this planet is multiply mutant. Okay, we've all got roughly 100 new mutations more than our grandparents. So just to demolish any argument that can be provided then through mutation count mechanism, which is kind of what you're hinting at, or equilibrium, or synergistic epistasis, we can, for the benefit of the doubt and sake of argument, Marshall, what we can do is we can just say, okay, let's get rid of the worst mutants. Just get rid of them, okay? Well, what we're still left with, since we're all multiply mutant, okay, every human being on this planet has mutations that have been inherited. You're still left with what? Okay, let's say you got rid of 50% of the worst mutants. You're still left with a population of 50% of people who are more mutant than the generation before it. Do you see? So consistently mutations build up and lead to degeneration rather than an equilibrium. Or so yes, the process can be slowed down, but it can't actually be stopped. And that kind of addressed your points there. So I yield. Take as much time as you want to respond to that, Marshall, and then you can ask me a question.
Okay. Well, like I said, I'm not a geneticist. The cursory look I've looked into it is basically that they don't observe genetic entropy occurring as a they don't see it as a serious problem. I have a couple of different questions. I would I'd like to know how you respond to the idea I put forth that if genetic entropy was a serious problem, it would be much more of a problem for species with a much shorter lifespan. And then the other thing I was going to ask was, how do you tell the difference between mutations and created heterozygosity? And then also, it's not really a question, but just kind of a rebuttal on when you said about how everything had more, everything lacked mutation at creation, right? Everything was perfect. But the problem is that the major bottleneck happened how long after creation did the flood occur?
After creation?
Yeah.
Yeah. So if it happened roughly 4,200 years ago, so you're looking at.
Okay. So you'd still have 4,200 years worth of mutations built up in the genome. So I don't think a perfect genome can entirely fix the problem of the major bottlenecks from the arc. But the more important thing I was wanting to know is how do you answer the critique that if genetic entropy was a serious concern, then things with shorter generation periods could not have lasted for 6,000 years. And then the other question I want to know is how do you determine whether something is a natural mutation that you would observe just as a result of genetic drift or whatever, or actual endogenous retroviruses being inserted versus created heterozygosity.
Sure. Okay. So I'll start kind of near the end. So how do we determine what is created, what's a created DNA element rather than due to mutation? Well, the simple answer is we have to look to allele frequencies. We would look to the common variants that are not disease causing and that are functional. That would be a strong indication that what we're looking at is created. If it's disease causing and it's rare, then it's probably a mutation because if we start from that front-loaded genetic diversity starting point, okay, and we're looking at the vast majority of these variants being created, then we can look around the world and we can see how many common variants there are. And what we actually see is roughly 10 million common variants that we found around the globe, okay? Marshall, as a matter of fact, to make it understandable, we have DNA differences, okay? You and me at about 3 million places. That's why me and my wife can hypothetically, if we could live long enough, we could have 1 million kids and they'd all be different because we have built-in heterozygosity, okay? So that means if we alone have 3 million, okay, places that are different. As in, if we were to look at, say, one chromosome, we would find one place where we got a different letter from dad than we got from mom. Okay. So we alone carry 1/3 of the world's diversity. So if we got about 10 million common variants around the globe, that means God would have only had to front load Adam with about 20 million. At the flood bottleneck, half of those could have been lost. Even though it was one generation followed by rapid and exponential growth, I doubt that much would have been lost. But let's just say, for sake of argument, half were lost. Well, we still have today 10 million variants that can go right back to the ark, and we can determine that those are created because they're not disease causing, and essentially they're functional. But when you find rare allele frequencies around the globe that are kind of isolated to different people groups, then you can safely say that is a mutation. Mutational load at the flood would have still been minimal, though, because if you're living in a pristine environment, mutations are building up, and then you have the flood, and then you have drastic change in environment where radiation, many other negative environmental conditions, because we know oftentimes environment is directly related to phenotype and genotype, then we might have, the accelerating of mutations. But your last question, or I guess your first question, because we're going backwards, was bacteria. And why aren't bacteria extinct? Well,
or mice or insects.
Okay, so one thing then, are you familiar with Lenski's experiment at all?
No.
So I find Lenski's experiment to be fascinating. It's the long-term E. coli experiment, I think the longest running evolutionary experiment to date. And what they're finding is his bacterial populations, they have experienced reductive evolution. So it's funny because we would predict that bacteria would be the most resistant to genetic entropy. And yet when we looked at this experiment, we are finding that these bacterial populations have actually painted themselves into a corner. They're getting rid of genes short term, but it's long-term degeneration. That's exactly what reductive evolution is. That's what we see in the fossil record for the most part. So even this bacterial experiment is revealing clear evidence of genetic degeneration. But we would still predict that bacteria, something like a bacteria would be the last to go extinct because, as you know, population sizes are massive in bacteria. Okay, the number of bacteria in the world is clearly massive. They have a very low mutation rate.
2-minute warning.
They have a very low mutation rate. And so these things combined is the perfect recipe for natural selection. Because if you were to just imagine, Marshall, this is the last thing I'll say, and then I'll hand it to you for some final words. Imagine humans reproduce the same way that bacteria did, okay? Because bacteria reproduce roughly let's say their generation time is every 30 minutes, okay? Well, the type of reproduction rate that we see in bacteria is ideal, like I said, for natural selection. It's perfect for natural selection. If humans reproduce that way, we would have 7 or 8 billion people in the world today, as we see, and then double the population every 30 minutes. Okay, to keep the population stable, you'd have to kill off 7 or 8 billion people every 30 minutes. So the point is, bacteria, these simple organisms, we would expect they would resist genetic entropy the most, but it's still pretty amazing that even in the most popular bacterial experiment, we still find genetic degeneration and reductive evolution, which is not helping pawns come to people evolution. Go ahead, Marshall. What are your thoughts?
Well, like I was already pointed out that, asexually reproducing species are more susceptible to this sort of thing, because essentially what you're having is, since they're not sharing genes, each individual, it could be considered like its own species in a sort of way, if you think about it. We would expect to see certain strains of bacteria die off. I don't think that's a problem. But my point was that if each generation the mutations build up, I still don't see how you would have anything surviving that long with such short generation time.
What would be an example?
We gotta wrap this up, you guys.
Well, I mean, we could look at for example, shrews or anything that breeds quickly, rats, rabbits, mice, that sort of thing.
Well, we
If
still
they
see irregularities in those types of genomes. We see irregularities in chromosome numbers, chromosome in genetic information, where we do actually see a form of genetic degeneration. And the problem is we have to sequence those genes. We have to consider reproduction rate. We have to consider mutation rate. And there's actually a paper that demonstrates that most mammals actually have roughly, and you got to determine things like generation time, but for the most part, mutation rate are relatively the same. And therefore, whatever species are still going today, obviously have not been around long enough to experience genetic degeneration. Now it's humans that we've studied so much that we see so many diseases building up, thousands and thousands of genetic related diseases. We see genetic sickness. Essentially, we also see epigenetic degeneration as well due to environment. But I want to give you the last word, Praise. If you just give us one more minute, because I do want to ask,
Sure.
in order to be fair, so then Marshall, I guess, has a chance to ask a lot of I know we asked each other a lot of questions in the opening statement. I'm just curious, how do you explain, because if we're looking at Ancestry and we're just going to go as close to home as possible, we got chimpanzees and humans. Well, what we find is every single Y chromosome in human males obviously is nearly identical. And they only go back just a few thousand years actually to a Y chromosomal Noah. That's based on observed mutation rates and number of DNA differences in the Y chromosome when we look at these phylogenetic trees. But that being said, the human and chimpanzee Y chromosome, this is a secular paper, Marshall. So this isn't creationists making it up. And they are admitting chimpanzee and human Y chromosomes are remarkably divergent in structure and gene content, less than 35% dissimilar. So if humans and chimpanzees split from their common ancestor, let's say 6 million years ago, how do you account for such drastic differences in the Y chromosome, which is non-recombining DNA, by the way, Marshall? So it should be more stable. Yeah. What are your thoughts on that? And I'm just kind of curious.
Well, I would have to, I'd have to look into it. This is the first I'm seeing that paper. I do know that humans are thought to be very similar, because there was that we've as far as I know, it's still accepted that there was a bottleneck between humans. So it is well known that humans are very similar to each other, versus how much they that there's not a very much diversity within the human lineage compared to some other species. I would have to look at the data and ask the question of, well, is the difference between humans and chimpanzees, is it greater than the difference between humans or gorillas and chimpanzees, or humans and gorillas?
Actually, I will say this.
Mm-hmm.
Actually, I will say this because you brought that up. The Y chromosome in humans and gorillas is more similar than humans and chimpanzees. So how would you explain that then?
Yeah, that's the first I'm hearing about that. I know whole genome that humans and chimpanzees are. Like I said, I'd have to look into that specific claim, but I do know whole genome studies show that humans and chimpanzees are more similar to each other than humans are to gorillas, and chimpanzees are to gorillas. But, and definitely humans are more similar to chimpanzees than to, say, orangutans and the other apes.
Okay.
So maybe we should conclude this. That was a fascinating debate, you guys. Very amicable discussion too. So that was respectable. I think the audience really loved it. We have a huge amount of questions and super chats we got to get to, but I know you guys have a concluding remark. So since SFT started it, maybe you can end it, SFT. Marshall, if you want to give your conclusion, that'd be awesome.
I think what we should do, to be fair, it's up to you, Marshall, but since I started, I can start and you can have the last word. But if you want to do your concluding statement first, that's fine with me too.
However you want to do it, I'm fine either way.
What's that? Sorry, brother, you broke up there. You want to go first?
Yeah, if you want to go first, that's fine. I don't care either way.
Sure. Okay. All right. Let me get my notes here to make sure that I've addressed everything. And praise. Okay. You can start the clock now. So, I want to thank Marshall for a really good debate. Lots of fun, tons of great points. discuss. But I think it ultimately still goes back to the fact that if we're going to answer the question of ancestry, well, we can't look to the lines of evidence that are agnostic to the debate. Okay, homology, nested hierarchical patterns, even mosaic-like forms are consistent in both models. And yet, even though they're consistent, we still find so many inconsistencies in the evolutionary phylogenetic tree, okay? But since these are agnostic, we need to look to lines of evidence that are not agnostic. Are those nested hierarchical patterns, are they there due to descent? Okay, hierarchies by descent or hierarchies by design. And that's where the DNA function related predictions come into play. And that's where I believe even people like Erica, go watch my debates with her since he brought her up, Marshall, they haven't answered this question as to how can these functional DNA elements go from non-functional to functional. Orphan genes, no real explanation for how these taxonomically restricted genes can come about. They have looked to de novo gene synthesis, but that is circular because they see these orphan genes that are essential. Okay, they don't have any empirical data that actually shows these popping up from these non-coding regions, but they assume evolution. They assume fish to fisherman evolution. So they have to say, well, these must have come about by non-coding RNA sequences. So it's circular. Okay, de novo gene synthesis. Why? Because orphan genes exist. Oh, orphan genes exist. Why? Because de novo gene synthesis. So these evolutionists, unfortunately, hang around the campfire arguing in circles for hours and still, instead of admitting that, okay, obviously separate ancestry is better supported by the data. And that's why in my opening statement, I spend a great deal of time on these phylogenetic trees. Got a Y chromosome phylogenetic tree here, and we've got the mitochondrial DNA phylogenetic tree. We know the mitochondrial DNA mutates incredibly fast, okay, right here. Regardless of the cause, evolutionists are most concerned about the effect of a faster mutation rate. For example, researchers have calculated that mitochondrially, the woman whose mtDNA was ancestral to that of all living people, lived 100 to 200,000 years ago in Africa due to phylogenetic rate. Using the new clock, using the empirical rate, she would be a mere 6,000 years old. So we like the empirical rate. And with the amount of DNA differences that actually separate any two people, because I've debated PhDs on this, somebody by the name of Dodgeball Dan, who he's won many awards in dodgeball. And their best arguments when it comes to genetic drift, when it comes to purifying selection, when it comes to bottlenecks, they fail because what we're looking at on these phylogenetic trees are too few differences where, given the fast mutation rate, we can account for purifying selection, bottlenecks, genetic drift. Plus, we have bottlenecks in our model where we would have rapid fixation and new mutations, faster substitution rates after the flood, easily accounts for average 20 to 30 DNA differences that separate any two people. Okay, we got a starburst pattern, explosive growth from a center point. Same thing with the Y chromosome. And it's just so funny because the evolutionists want to say things like, well, you have to account for the phylogenetic rate selection, but they're the ones that are not making the testable predictions. So we look at the data as creationists, and we're the ones actually making the testable predictions. So for example, we have a paper here by Dr. Nathaniel Jeanson, evidence for a human Y chromosome molecular clock, pedigree-based mutation rates, which is the empirical method, not the circular method, where the circular-based method, where they want to assume the geological time frame and assume when we would have split from the chimpanzees. And another problem is he was pointing to genetic similarities between humans and chimpanzees. Well, the Y chromosome dissimilarity is still a massive problem. I've had 100 debates. I bring that question up every debate, never get an answer. Even from the best of the best, they all fail miserably. The best you'll find is a couple hypotheses that actually haven't been tested. You won't find any numbers. They just can't admit the obvious. Plus, you got the human and gorilla Y chromosome that's more similar to each other than the human and chimpanzees. But the number of DNA differences that separate humans and chimpanzees now, since what the scientists of the genetic sequencing when it came to humans and chimpanzees did was they ignored gaps, copy number variation, unalignable regions, and it's actually more like 88% similar, which is hundreds of millions of DNA differences that separate humans and chimpanzees. And we know fixation rates are incredibly slow. So now we've got a waiting time problem. How do you fixate all of those mutations in just 6 million years or so since the split? It's a problem, massive problem for evolution. So the last thing I'll say, and then I'm done, is right here, testing the predictions of the young Earth Y chromosome molecular clock. We have confirmed predictions that the evolutionists ignore that flow from the empirical data that suggests mitochondrial Eve and Y chromosome Noah lived just thousands of years ago. Their DNA sequences are nothing like the chimpanzees, which confirms separate ancestry and refutes universal ancestry. And that's the topic of this debate. And I believe I met the burden of proof for the debate. I yield.
Great. Thank you, SFT, for your concluding remark. Marshall, you're next, and then we'll go ahead into the questions and answers and also the super chats. We got a bunch. So whenever you're ready, Marshall, go ahead.
Okay. Real quick, I just want to shout out Landon Freeman in the chat. He said, thanks for agreeing to debate, Marshall. Hope you feel better soon. Thanks for your kind words, man, and thank you for everybody else in the chat that's showing encouragement. Yeah, I'll admit I haven't done very well in this discussion, this debate. I definitely do need to do some more research on some of these genetic problems. But I will say that the people that know a lot more about genetics than I do, or than standing for truth, reach a separate conclusion. I don't think it's an argument from authority. I keep going back to the scientific consensus. But if you don't really know much about it, and anybody watching this, I encourage you to go to the scientific literature and the and see what the vast majority of the people actually studying this that are not bound by the rules of a creationist organization. See what conclusions they come to on these questions. I was hoping we could get a little more into morphology and specifics on phylogenetics, but I know we don't have a lot of time there. If you do feel like you have proven this, then go publish some stuff and prove it to the rest of the scientific community. I'm not a scientist, and nothing is going to change as far as science, based on these kinds of debates. But it is fun to try to come up with ways to explain, defend the science, and it helps me learn more about it. So I appreciate standing for truth for taking the time to do this. I'm still not really seeing any clear delineation between what could be a created kind and what isn't. You say that if it's beneficial, then it's created heterozygosity, and if it's rare or not not beneficial, then it's mutations. But that kind of seems like like begging the question a little bit. I don't really see how that sets forth a clear methodology for us to tell the difference between a created gene versus one that arose through natural mutation. And he kept throwing out predictions, and there are predictions that evolutionary scientists did make. We predicted that we would find Tiktaalik exactly where we found it. Even if Charles Darwin predicted we would find a bird with unfused wing bones, found that while he was still alive. We found Archaeopteryx not too long after. We found Indohyus, Pachycetus, and all the range of fossils in between, humans and our last common ancestor with chimps. I predict at some point we will find the last common ancestor between humans and chimpanzees. I can't wait till that happens. So I just encourage people, watch out for charlatans and people who are obviously, people on either side who have a clear agenda, and it seems like they have started with the position they want to defend and are not open to looking at what the evidence actually says, and look into what the science really says behind this. Because the consensus is overwhelming, and there are many different converging lines of evidence, and you can you can pick at each one and explain it away bit by bit, but the totality of evidence is still there, and we have yet to really see a mechanism for how creation could happen. You know, maybe some point we'll see exactly how things can be made in this sort of way. But, you know, we also have the answer of abiogenesis to answer on our side of how exactly that came about. You know, so there's some exciting things to find on both sides. And I think if you just, you know, decide that you have the conclusion and you're not gonna look for anything else, then you really hit a dead end. So I think on both sides we need to just keep looking for answers.
Awesome. Great debate, guys. Now we're going to head into the question and answer portion, the super chats. We got quite a few. Some of these are just comments. You guys don't have to respond to them. You can just go on to the next one. But the way we do it is whoever it's addressed to, they finish the very last part of it. So like if, let's say that's to you, Marshall, then if SFT respond to that, it would end up with you. So we'll just go. Okay. We'll do it that way. So the first super chat is from Jerome M for $5. Thank you, Jerome. Awesome, brother. For Larry Nelson, aka Aaron Blah. So he has 3 exclamation marks. Larry Nelson. Is that? Wait a minute. Is that Aaron Raw, right?
It's Aaron.
Praise. That's your best buddy, Aaron Raw.
All right, so we'll go to the next one.
Support. I appreciate the support, Jerome.
Next one is from One God is Nowhere One, and for $25. Wow, very.
Hey, I want to be fair to that guy. I've talked to him before. It's God is now here, because I've made the same joke to him. It's not God is nowhere. It's God is now here. He's yeah.
I've made the mistake 30 times.
Wow, face palm on that one. Okay, so here's some tuition for the education SFT offered up to Marshall tonight.
I appreciate all the support in the super chats. And Marshall, I do want to thank you for doing this debate, and I hope you feel better. And thanks. I think it was a good, cordial, professional debate. To be honest with you, I mean, 2 hours flew by, so I want to thank you again for that.
No problem.
Very good. We have one from Satan. Oh, trolling. I'm just kidding. This guy,
the devil himself watched this debate.
Some stock account, but $14.99. SFT, Raw, Matt, George, Bon, Octavio are the Fantastic Four.
If we add you in there, Praise, we can be the Avengers. Avengers can beat Fantastic Four, so that'd be cooler.
Yeah. Yes, that's kind of funny. I think he's trying to troll us a little bit. I'm not sure who that is.
Who would I be then? I don't know if I call myself Thanos. Can I be Loki?
You could be Doctor Doom.
Doctor Doom? All right.
No, you could be Loki. Yeah, Loki's cool. I like Loki.
So we got super chat from Bread of Life for $5. Marshall, sorry you are sick. Thanks for being here.
I appreciate it. I appreciate the kind words.
Very good, very good. We have one from Ramen Goiza Dango for $2. Phone a friend to Erica, please answer. Oh, trolling you, Marshall.
Man, I would pay money to have Erica here doing this debate with me or doing it for me. Sure, she is much more well educated on this stuff than I am. I would yield to her entirely.
I will say
huge fanboy.
I will say one thing. For one, we've debated 3 times and have touched on a lot of this. But one thing that you said, Marshall, since it's related to the super chat praise, I'd just be curious, based on your response when it comes to the mouse genetic knockout tests. For one, they've actually done knockout tests. I've got a paper, it's Q&A, I'm not going to screen share, where they've actually knocked out a lot of long non-coding RNA genes, and they were lethal. Plus, certain classes of retrotransposons they're knocking out, they're proving to be lethal as well. But the thing is, the ENCODE project has actually revealed that at least 80% of the genome is active. Now, we don't really know exactly what every genetic sequence does, Marshall, because we haven't done extensive knockout tests on humans, right? It's unethical, so thank God we're not doing that. But the point is, we see 80% activity. Now, is that activity spurious? Is it useless? Or is it useful? So we as creationists on paper, we're making predictions that yes, this activity is useful. It's beneficial. If you knock out this gene or just this gene, it'll lead to disease because that gene is healthy and necessary. So the point is, and the question I want to ask you then, if you want to still hold to the answer you provided, Marshall, why is all that activity there? If it's just useless, according to you and Erica, why hasn't natural selection gotten rid of that over millions and millions of years of evolution? Because that uselessness would just be wasteful of energy and resources for the cell. What are your thoughts on that, Marshall?
Well, I think the way, if you look at the way Richard Dawkins explains, what an organism is, it's just a vehicle for a gene to reproduce itself. If the gene has, is being conserved, if the gene gets reproduced, it's going to stay there. Evolution doesn't work towards what is ideal. It just works towards, what works, basically. And again, I don't think that, I'm not arguing that it's all useless. Sometimes some of it can have a function. The question I would have is, there's some genes that we find that are switched off, and then we switch them back on, and we can see that it does something. It makes a change that doesn't, really do it, help the organism. For example, like we can turn the genes for teeth back on in chickens. So how would you explain that?
You're saying we have a chicken gene for teeth. We turn it, we manipulate the gene, and the chicken grows teeth.
Mm-hmm.
So you're saying at some point the ancestor of chickens had teeth and now lost the ability for that because the gene was turned off?
Yeah, that happens a lot. With species, is that you'll have a change happen where some trait is lost, but the genetic information for it is still there. It just gets switched off.
Right. So my point is that would just be another example of devolution, because we have the epigenome, which is a massive control system that works to turn genes on and off. So since we have had many, many generations of genetic degeneration, it's not a surprise that we can turn certain genes on that maybe have been turned off or damaged. And in the case of the chicken, we got a tooth showing that at one point, the ancestor of chickens, or we've seen birds in the fossil record, true birds with teeth. So therefore, they've lost the ability to grow teeth. That doesn't seem to me to help evolution, because it just seems to be, once again, loss of information, genes being turned off, genetic degeneration ultimately. So I don't see. I want to say one thing to what you said. Actually, no.
Well,
go ahead.
I mean, a bird's beak isn't just like a toothless mouth, though, right? It is a different structure that operates. They have something else that does the same function as the teeth. So I don't think that's an example of de-evolution. It's not like it's just losing teeth and has nothing left to chew its food with.
Oh, right. Well, obviously, organisms can, like, for example, we could essentially lose certain. Like, I could lose one hand, and thank God for redundancy, because now the other hand, I could still survive. Or essentially, we could all lose the appendix is useful in the immune system, and it's useful for harboring good bacteria. But the human population could theoretically lose the appendix somehow through degeneration, and we'd still survive, because the body can oftentimes adapt, and the body can compensate for losses in different areas, because it's highly designed and complex to do that. So my last question to you then, before we move to the next question, then I'd be curious, after all of this, how much of the genome, both non-coding and coding, would you predict is functional on a percentage-wise then?
I'm just going to be perfectly honest and say I have no idea. I'm not a geneticist. I don't know. I'm not. But I did want to talk a little bit more about the birds with teeth thing, because that would seem to indicate, if you use that explanation, that would indicate that the ancestors of birds had teeth. So either all birds share a common ancestor with something that had teeth, or they all lost teeth independently.
Well, we have cases in the fossil record where we have true birds,
right,
with teeth.
Well, no, actually, no, not true birds. They're not aves. They're not. Anything that's in the class aves doesn't have teeth. They're bird ancestors, not true birds.
The problem is when it comes to classification systematics, evolutionists assume evolution to prove evolution. So you find in the fossil record a lot of animals that we see today, but a lot larger, okay, with different variation. But what they'll say, because they're assuming common descent, which means it can't be complete stasis. So they'll say things like, well, this is beaver-like, or this is bird-like. Well, no, what we're looking at is true bird, true beaver, true horseshoe crab. What we actually see is stasis. But the further you go back, according to our model, we have organisms with a greater ability to adapt because they would have more heterozygosity at time. I mean, the creationists, we look back to the creation event and we see the expansion of genetic information. You, Marshall, you look back to your first single-celled like ancestor billions of years ago and you see the contraction of genetic information because you got to build up genetic information.
We got a bunch of to
yeah,
go.
That's true. That's true.
I would love to talk more about this birds with teeth thing, but we can move on because this is a fun.
Yeah, good discussion nonetheless. But we'll go to George Baum for $5. How do feedback systems evolve? The example, the hypothalamus. And I guess that's directed to you, Marshall.
Ooh, that is a good question. Feedback systems, how do they evolve? You know, I'm not too familiar with the example they gave of the hypothalamus. You know, if you have something that works, you know, sometimes we do see a function working in one way and then it switches over. It can be co-opted for another function. I don't see how there's a problem with feedback systems evolving though, because if it's being selected, if each part of it is being selected for at the same time, it can develop over time. I don't see how there's an issue with that. I wish I could give them a better answer, but I'm not really sure what they're referring to.
Appreciate the answer. SFT, want to respond to that?
Yeah. I think there's so many problems in evolution, just like the problem that George is putting forth, where I find, you know, Darwin himself was more, and Marshall, I'm not saying you're not us. I'm just saying if you read a lot of what Darwin said, he admitted that a lot of these problems that we see, he hopes one day, you know, they will be answered, obviously. But now it just seems like evolutionists, they kind of sweep away the problems because, yeah, there's problems in reproduction. There's problems in just explaining how evolutionary mechanisms like natural selection and mutation. Natural selection sees the short term. So like in my opening statement, how does natural selection evolve the epigenome, which requires forward thinking and therefore a forward thinker? For example, how do you evolve a spare tire, right? That requires somebody thinking ahead. Oh, maybe I'll get a flat tire on the road and therefore I'll need the spare tire. Thinking ahead. Redundancy is good design. And now what we know about genetics and the ENCODE project and follow-up projects as well is that what we're dealing with is a 4-dimensional genome that's nested with multiple overlapping codes that's chock full of meta information. So how do evolutionary processes evolve that? So with what George said and the epigenome and the 4-dimensional genetic code and all of these complex structures, yeah, evolutionists really do have a hard time explaining how these came about, how these evolved, because typically when they do attempt an explanation, now they're giving evolutionary mechanisms a mind, or they're just kind of telling a story. Yeah, I yield, and it was Marshall's question, so he can have the last word.
Go ahead, Marshall.
Well, you know, Darwin definitely didn't have all the answers. You know, his theory was very rudimentary. You know, we've solved many of the problems that he had, and we've also found many new problems that he was never even aware of. But that's the fun thing about science, is that there's always a new question to answer. And I think that if you just say, well, it must have been God, then that kind of eliminates the question of like, why, how did it happen? You know, so there's a lot we don't know yet, and there's a lot lot to learn.
Very good. So we got kind of a lighthearted question for you, Marshall. Does evil twin standing drink? So do you drink coffee? The evil twin of standing. This is from Ramen for $2.
Are you a coffee addict like me? Is the question.
Unfortunately, I've tried to quit many times, and
Oh, don't
I
try
always
and
end up coming
quit.
back
No.
to it.
That's no fun. The one thing I look forward to when I start my day is a nice cup of coffee. You don't want to quit that. It's good stuff.
I just don't like that when I don't have it, then I'm useless.
Don't talk to me until I've had my coffee.
Yeah, we'll get on to the next one now for $5 again, Ramen. Thanks again, Ramen.
Thank you, Ramen, for the support.
Absolutely. Marshall, if your consensus friends jump off a bridge, do you jump also?
Absolutely. If they jumped and were fine, then why not?
See, here's the problem, though. For one, the scientific consensus has oftentimes been wrong all throughout history. But not only, most importantly, okay, what you find is the evolutionists, they'll say, well, the creationists are invoking a conspiracy. If all this data really is true and it points to separate ancestry and biblical creation, then why isn't the majority of scientists on board? Well, like I explained in my rebuttal, and this is a fact, the majority of people who went on to get their PhD and become evolutionary biologists or scientists in other fields, okay, they grew up in homes where they didn't even know anything about young earth creation. They didn't know anything about the separate ancestry model. They went to secular universities. They've never once read a young earth creation technical paper. For example, these technical papers that have been coming out over the last year and a half that demonstrate successful confirmed predictions on the Y chromosome, the mitochondrial DNA, and the history of civilization. You talk to 99.9% of PhD scientists, and they won't know about it, and they won't have any answers because they've never actually sat down and looked at the other side. And that's kind of sad. So it's not a conspiracy. It's just the fact that the majority of scientists aren't aware of the data, and the ones that are and have attempted to refute it really haven't, because all they've done is put forth rescue devices, but yet have not offered their own testable predictions. And Marshall, I think, would agree that the gold standard of science is to make testable and falsifiable predictions. So the evolutionary community needs to meet that standard and make better testable predictions. I yield.
Yeah, you can quickly respond to that if you want to.
I would say they would probably read those papers if they were posted in actual scientific papers and not creationist sources. And also when the consensus of of common descent developed, there was no people weren't being brought up being taught this. It was something that developed over time. So you have to explain where it originated, not just saying that people are brought up to believe the opposite. Because most people at the time of Darwin and Lyell and all that were young Earth creationists. Well, were creationists anyway. I don't know if they are.
So we'll go to the next question. George Bond just sent this for $5. Thank you, brother George Bond. And he says, SFT is too modest to inform you. He holds 10 PhDs. Oh!
10 PhDs, all from Harvard and Yale. And I got all those PhDs in a matter of 10 years. There's two of them behind me. So if you want, I can get my daughter to make you one as well.
Okay. Nice. Well, you need to step it up. Nephilim Free has like 10,000 degrees.
10,000. I'm going to have to live a million years for that. Or 10,000 years, one a year. But really, thank you, George. I appreciate the super chat, brother.
All right, so now we're done with the super chats. We're going to the questions. Our first question is from Landon Freeman to Marshall. How do you explain organisms that have been in stasis for incredibly long periods of time? Their stable environments would have been repeatedly upended, necessitating evolution.
Well, that's a good question. When we see these forms of stasis, it's usually it's the stasis is in like the overall form. We do see changes in speciation. For example, the coelacanths we have now are not the exact same species of coelacanth we found in the fossil record. Many things like that. They do change in in less obvious ways. But there are some niches that just work really well. For example, crocodiles have just done really well sitting and being ambush predators, and it just doesn't require a whole lot of changes. But if you go back to the early, I think the early Triassic, you can find crocs that were running around, galloping on 4 feet, and crocs that look, all kinds of different variations on the basic crocodilian form. So yeah, I don't think it's that unbelievable that some species would just settle on a thing that works and not have significant changes to their overall morphology.
Praise, if I could respond to that, it's a good question. I appreciate the answer, Marshall. So that answer to me assumes evolution to prove evolution. And I think sometimes the best way to refute a worldview is to assume that worldview, okay, and then see how it flows from the data that we actually have. So yes, we see stasis. Yes, the coelacanths, for one, the coelacanths and the finding of them today was actually a surprise. Okay, because what they said about the coelacanths is they were on their way, evolutionary speaking, to becoming something that could crawl up on land, obviously is not true based on what we see today. But we wouldn't expect the coelacanths to be exactly the same, even according to the creation model, because the animals we see today, okay, the wolves, the domestic dogs, of course, what we see is shifts in heterozygosity to homozygosity when it comes to speciation events and changes. So the further you go back in time and the closer you get to the creation event, we're going to expect more variation for the most part in these organisms, and therefore they're going to reflect that in their phenotype, and they're going to be a little bit different in terms of morphology, but nothing different in the sense that, wow, this is 250 million years worth of evolution, and we've got these couple minor differences here. That stasis really is better supported by the creation model. But to steelman the position, my question to Marshall, and I'll let you have the last word here because it was your question. If we just look at the number of species today and assume what you're saying is true, okay, well, we actually, and we can talk about this in a separate debate, I've got all the numbers here on the species that we have, okay? And we actually see far too few if evolution, deep time evolution is true, okay? So for example, we actually see new bird species evolving today. Here's a new paper that has come out. This was after a prediction made by PhD scientist Nathaniel Jensen, who predicted that we should roughly find, 2 to 3 new bird species a year for 4,500 years, given the fact that we've got between 10 and 18,000 bird species, okay? He also predicted that if the created heterozygosity model is true, if there's any validity to it, we should find these speciation events being consistent with shifts from heterozygosity to homozygosity, which makes sense given that model. Yet what we see, confirmed prediction, new bird species has evolved on the Galapagos Islands, okay, in the same way that was predicted by Nathaniel Jensen. So here's my question to Marshall. If we're seeing new bird species in real time, but yet we only see between 10 and 18,000 species, okay? And I think 18,000 is being generous to the evolution. So even say that. But yet you want to say that birds evolved from theropod-like dinosaurs hundreds of millions of years ago, and yet we're seeing new species form today. Why do we only see between 10 and 18,000 bird species? Why don't we see millions of bird species? I'd be curious to hear your answer on that, Marshall.
All right, well, that's actually pretty easy to answer, I think. The simple answer is extinction. When you have an ecological niches are limited. So when you have two species closely, competing for the same niche, what you often see is one will outcompete the other, and they go extinct. So there's actually kind of a limit to biodiversity in many areas, just because if you have many different species competing for the same resources, then if one is just a little bit better at it, then the other one is either going to have to change their strategy and evolve into a different type of species, or they're going to go extinct. That's what we see this happen with invasive species, where you bring in something like a dingo to Australia, and then they've wiped out the thylacine on the mainland, or you bring in a Nile perch into the Lake Victoria, and they've wiped out so many different species that these ecosystems can only support so many species. So you're going to have things going extinct and things evolving. Really, the problem for the creation model is that there's just way too many species in the fossil record. If all the species that we have found were alive at the same time, I don't see how there would be a niche for every one of them. And I'll let Standing respond to that.
Yeah. So good points. And I find your answer, though, makes your answer unfalsifiable unless it leads to testable predictions, because that means we can, and I'm not going to, for sake of time, we're in the Q&A, I could share a screen again and we could look at lizard species, snake species, bird species, rabbit species, mammal species in general. I got all the numbers. Creationists are making predictions that, okay, this many kinds were on the ark. This is how many of these species exist. This is how many we see in the fossil record. Therefore, we predict this is how many speciation events we should see today. And the types of speciation events we see should be consistent with the created heterozygosity hypothesis. And yet that's what we're seeing. And we're actually putting it on paper and making predictions. But for your explanation, unless you can make predictions, so obviously you're not going to have it now, that's fine. Maybe afterwards you can provide some papers that show predictions in terms of, okay, we see 10 to 18,000 bird species today. We predict there would have had to have been this many extinction events, and this is the speciation rate we should see today. We can't just say things without backing it up with the gold standard of science, which is prediction. So I think the creation model is stronger in terms of speciation events because the numbers actually line up perfectly. Contrary to what you said, they line up perfectly with the flood bottleneck. We also know that speciation events can happen quickly. I got a dozen papers here that show rapid adaptation.
Are we going to wrap this up? And Marshall, you can quickly let him.
I'll give Marshall the last word. Yeah. So
we got to make it pithy, though.
Yeah. So my question, I guess, and then you have the last word. Would you be willing to find some papers or somebody who's making testable predictions where we can look at that extinction event answer? Go ahead, Marshall.
Yeah, I would be willing to look at some papers. I was just using, just kind of basic knowledge in that, we know extinction events happen, and we know speciation events happen, and we know that, species need to be in some sort of ecological equilibrium. So I don't think it's a problem for the number of species is not outside of what we would predict. I think the bigger problem for the creation idea is, how do we get so many species of elephant so quickly off the ark? So many species of different types of horse. And there's I think especially when you look at the animals that have a longer generation time, it becomes a little more difficult to explain where all these species came from. I don't think we see speciation happening quite fast.
All right, so I got to jump in really quick because we have a super chat. We got to get through our super chats because they're paid, and we just got to get through those.
I was done. So.
Oh, awesome!
No problem. No, it's going good.
So I don't know how many more questions we can do because I know we're going on 2.5 hours. So this might be. What do you think, guys? Do you think we should do more questions? Are you guys ready to go? Are you ready? You ready to stay longer? It's up to you guys.
I'm cool with whatever.
Yeah. I mean, it's okay. 2.5 hours. There might be some after shows. Yeah. Maybe we'll start winding it down. Get through the super chats. Maybe one more question, and then we'll call it. We'll call it a night.
All right. So this is $5 from Jamie Russell. The published literature. I'll coom a boot. God did it. I'm not sure what that is. I'm not sure.
I think that's a Canadian trying to say that the published literature doesn't say God did, or does say. I don't know. Hey,
I'm Canadian, and I don't sound like that. Or maybe I do. I don't know. People say I say a boot funny. I will say this, actually, just based on what he said. When it comes to the published literature, and then Marshall can have a response too, before we start wrapping it up, is what we find, like throughout my presentation, I provided, a dozen or more papers from the secular literature. Now, what I find the evolutionists do, for example, Marshall, when you go read the Y chromosome paper and try and derive an answer, why is the chimpanzee and human Y chromosome so different? Why is the chimpanzee, or why is the human and gorilla Y chromosome more similar to each other than the human and chimpanzee Y chromosome if the chimpanzees are closest relatives, so on and so forth. I find the evolutionists, they leave critical thinking at the door because they'll go right to the conclusion, the conclusion or the discussion portion of these technical papers, and they'll just kind of blindly believe the hypotheses put forth to explain the data, right? Orphan genes, well, de novo gene synthesis. So because the authors concluded that must be true. Or the endogenous retroviruses, co-option. Okay, that must be true, even though they haven't demonstrated that in the lab. Or the Y chromosome, same thing. Or the mitochondrial DNA mutation rates. Well, we got to look to the phylogenetic rate and we got to calibrate it with the geological column. So my point is, the evolutionists, they should read the technical papers, look at the data, and then think about it objectively as compared to just blindly believing what the authors conclude. Because oftentimes what the authors conclude, okay, to explain the data, are hypotheses that have not actually been tested. So you should see, have they been tested? Do they result in testable predictions? Or are they just kind of trying to save the evolutionary story? Go ahead, Marshall.
I would actually pull a tu quo que and say, that I think everybody should do the same when looking at creationist literature and try, ask, are they taking an objective analysis of this, or are they just trying to fit it with their, their admitted starting point, their statement of faith or whatever. So I think it's something that both of us need to work on.
All right, so we could do one more. How about one more question? We'll probably call it.
Sounds good. Yeah, we'll call it at 2.5 hours. That's it. Yeah, that's good.
Awesome. So this is from Redefined Living. Question for both: do all scientists start from a presupposition? ? Do you really believe there is a neutral ground on this topic?
You want to go first, or?
Sure. Yeah, we've all got a worldview. We've all got presuppositions. That's why I pointed out earlier that the best way to refute a worldview, if I have a worldview, Marshall has a worldview, I need to assume Marshall's worldview, and then we need to see if there are inconsistencies. And when I assume Marshall's worldview, evolution, deep time, we can find inconsistencies. We can assume uniformitarianism with some catastrophism, and we can see that doesn't fit. He can do the same, assume my worldview, and see if there's inconsistencies. But for sure, we have a worldview. We make presuppositions. I mean, the secular literature, okay, they can question details about the evolutionary story, okay, but don't be blind enough to think that they question the bigger picture. No, they assume. I mean, I've got paper after paper showing that when it comes to these phylogenetic trees and cladistics, taxonomy, they admit they assume the tree. That's the first thing they do, is they assume the tree. They assume there is a tree, right? So any inconsistency like convergent evolution, they're going to fit it in somehow, okay? And they'll debate all day about the little details about what evolved from this, or why is the hominid family tree such a bushy mess? And, they got little disagreements, but they're not going to question universal ancestry. No, that's why the creationist technical journals are so important, because we're looking to the universal ancestry model, and we are looking for inconsistencies, and we're seeing if our model can best explain the data. So go ahead, Marshall.
Okay, so I was asking about what sort of presuppositions each side makes. Well, I don't think there can be any disagreement that many of the creationists have the presupposition that that the Bible is true, or that creationism is true, or whatever. Most of these organizations will admit that much. And science, of course, does make some necessary presuppositions. But the theory as a whole, I don't think it makes those sort of presuppositions, except that once you have an established theory that already fits all the evidence, you don't go back to the beginning every time you make a paper, right? If I'm making a finding about a certain, the way a certain bacteria causes disease, I'm not going to go back to the very foundation of germ theory. So once it's already established science, each new paper doesn't need to go back to the beginning to prove the foundation.
Very good. So this is our last question. I think we can fit this in here. So for SFT, do you find the evidence for microevolution convincing? If so, can you name some species?
The evidence for microevolution convincing?
Yeah, and can you name some species?
Oh, definitely the evidence for microevolution is real. I mean, we see microevolutionary variation within families. We see speciation events, as I've explained. We see speciation events in bird species. Okay, so oftentimes when you talk to somebody about evolution, the best thing to ask is, what do you mean by that word? Because evolution just means change. Biological evolution means a change in allele frequency in populations over time or over generations. So yeah, we see that. So yes, the evidence for microevolution is convincing. We see different species of felids. We see different species of dogs. I mean, look at the domestic dogs alone. Look at breeds. I mean, we have such amazing variation in breeds just through pre-existing DNA differences and recombination, shuffling those genetic differences and picking out specific traits. And with breeds, it's funny because you got to babysit them, because once you put them back into the wild, what happens? You know, they're not going to last very long. So yeah, speciation events happen, but microevolution doesn't mean macroevolution's true, because the changes we see in microevolution are typically downhill. Mutations degenerate. We see reductive evolution, like in Lenski's experiment. We see these bacterial populations are losing genes short term for adaptive purposes, but it's actually long-term degeneration. That's why you oftentimes see shrinking functional genome sizes. So my point is, yes, we see species. We need speciation events as creationists. We make predictions on speciation events. We agree with microevolutionary variation and changes, but the type of change is opposite of what would be required to take a single-celled like ancestor into a whale over billions of years.
I just want to point out real quick that the way evolutionary scientists use the term, make the distinction between macroevolution and microevolution, is that microevolution is anything below the species level, and anything above the species level is macroevolution. So if you accept speciation, up to the family level, then that's actually a form of macroevolution. So you would need to come up with a different term.
Right. But if you actually look at how macroevolution has been explained from Darwin up to today, as in the evolution of higher organisms, the evolution of complexity, novel structures, the evolution of anatomical novelty rather than just morphological variation.
It's the same thing. It's the same exact mechanism. It's just.
So is it your position that a single-celled like organism, bacteria-like organism billions of years ago, can evolve indirectly, obviously there's a lot of steps, into whales, humans, okay, elephants, through microevolutionary processes, mutations, natural selection, genetic drift? Is that your position?
I mean, when you take out all the steps in between, it's like asking, can a baby turn into a full-grown man? Well, yeah, but there's a lot more involved than just that.
But remember, from embryo to baby to human being, we have all these different developmental windows where we got genes being turned on, turned off, amazing control mechanisms that are what? Built in, right? We get the genetic information from our parents. That information's already there to build the human being. But if you start with your single-celled ancestor, is it your position that single-celled like organism billions of years ago had all the information built in like we see in development and growth?
No, it couldn't have.
It's not the same thing then.
So, but we do see, it's populations over time, and there were a few steps that I will admit are, difficult to get your head around. Like, for example, when a single-celled organism absorbed another single-celled organism, become the mitochondria. That sort of thing could have been a 1 in a trillion some odd chance, and it just happened to happen on Earth, and but
I mean, would you want to bet your eternity on a 1 in, would you say, a trillion chance? I mean, I'm not going to buy a lottery
the problem
ticket
is
with a 1 in trillion chance.
Well, it depends on how many planets are out there, right?
How many planets have we found life?
Well, we found other planets in the habitable zone, but my point is that with how big the universe is, even if it's a 1 in a trillion chance, if you have tens of trillions of planets, then it's going to happen, right?
So I guess my final word here, and then I'll give you the final word. We'll start wrapping it up since we're over 2.5 hours, is when it comes to like definitions and semantics and things like that, we need to look to the actual data. We need to look at the genetics. And yes, we see speciation events, but we see speciation events typically through, okay, you have a population that's, say, more heterozygous, and then you have a breakaway population where part of that population breaks off, they migrate, they get isolated, and they start inbreeding, and you get shifts now from the heterozygosity to the homozygosity, and then you get distinctiveness in morphology and also in genetics. So now we can say, okay, this is a new species. It's different enough to say this is a new species. But notice, all of that was due to reduction, isolation, loss of allelic variability. So I don't know how you're going to go from a single cell-like ancestor billions of years ago into a whale by losing information, by reducing the allelic variability is my point. And I understand you can believe that, Marshall.
I mean, that's just one mode of speciation. There's other modes of speciation. That may be the one we see the most because it's the easiest to observe. I don't see how you could say, for example, a lion and a house cat. Would you say they're in the same kind, or?
Yes.
So does it seem like they're like what would you have to like? I don't see how you can get from a common ancestor between those two without get some kind of gain in information by just losing information. That just doesn't seem believable.
Well, here's the thing. Now we got to look at the genetics. See, oftentimes the evolution, if they want to look to the phenotype to determine the change in the direction, we got to look to the genotype and see what's actually going on. What we see with the house cats, what we see with breeds, what we see with domestic dogs is still shifts in more allelic variability to less allelic variability. So that being said, starting from the position of created heterozygosity, the cat ancestor aboard the Ark wouldn't look like any cat today. But we know that cat ancestor would have been front loaded with a whole bunch of functional DNA differences. And through those DNA differences, we would have observable processes like recombination, gene conversion, breakaway populations, isolation, inbreeding, and we're going to get new species. And then you take those species and you start artificially selecting for different traits and different breeds. Sure, with those pre-existing functional DNA differences, we can now have two cats coming off of the Ark, and thousands of years later, we got everything from tigers to lions to house cats to jaguars and in between. Because all it took was shifts in that original heterozygosity. Yeah, go ahead.
I don't understand how you can have this type of heterozygosity in an individual. When we talk about heterozygosity, it's usually with a population. But if you're if you're down to just two individuals, I don't see how an individual can have multiple variants of an allele in its genome. It just doesn't work that way because many of these things are an either or type thing.
Well, what's your definition of an allele?
Well, an allele would be a gene that selects for a trait, right? It produces a phenotypic trait.
Well,
am I on the right track with that?
It's a variation of a gene at a specific loci. So when we consider how many genetic loci, how many genetic locations exist in the genome, okay, think of it this way. It's like you go back to basic genetics and you got big A, big B, little b. Okay, so if you're big A, big B, little b, you're heterozygous at that site, right? Now you have to apply that to millions of genomic positions in the genome. So now we have millions of sites that are heterozygous. And that's why I was pointing out, me and my wife alone, like you, Marshall, you have 3 million DNA differences in your genome. Okay, where one place is different. The place you got from your dad and the place you got from your mom are different. That's why me and my wife, or you and your wife, you could have 1 million kids, they'd all be different, and that's just 2 people, right? So
Well,
we
actually, I don't
have
plan on having
built-in
kids, but-
heterozygosity. What's that?
I said I don't plan on having kids, but
If you did,
I
I
get your
promise
example.
you have 3 that all look different.
But you understand what I'm trying to get at, right? Is that if you have, because we could, maybe this is something we might need to do some more research on. I think if you took a multitude of species within what you would accept as a kind, and then pick a certain location on the genome, and then if we could look and find that there are variations in the traits. And I don't see how you could say, like, it just doesn't seem like there could be enough room in the genome for all these specific traits to vary in the ways that they do. But we may be spending too much time on this. So.
Yeah, so we're going to need to wrap it up, and because there's an after show. I put my link in also the private chat, but also the regular chat of the YouTube stream. So just go there if you want to check it out.
So I would just say, as my last word is, I find a lot of people, they don't properly define allele. But when they recognize that we have an allele that is actually defined as a single genomic position, that's actually independent of its relationship to a gene, then we can certainly have in just 2 individuals massive allelic diversity generated through not only mutations, but recombination, because it's just shuffling up those pre-existing DNA differences, gene conversion. Okay. If you think about it, I'll say this. Take a single gene, Marshall, 1 gene.
Mm.
Well, 1 gene typically spans thousands of nucleotides. And then you have SNVs, okay, single nucleotide variants that are distributed throughout that gene. So at 90 of the nucleotides within the gene, if you correctly define allele as the genomic position definition, then every single one of those 90 SNVs could have existed in a heterozygous state in the cat ancestors that were brought on board the ark, or the dog ancestors. And this is all scientific. As I've pointed out, we alone have 3 million DNA differences, and we alone can generate change due to pre-existing heterozygosity. But like you said, we could have another debate and get more into like the speciation model and whatever, anything, phylogenetics. But I'll say this, because you've been great. You've been a guest here. We've been going on 2 hours and 40 minutes. I'm going to hand it to you for the last word on that, and then we'll kind of wind it down. So go ahead, Marshall.
All right. Yeah, I would just say that it'd be a good line of inquiry into validating your model if we could find these where these changes took place and where they're at on the different places on the genome, and if we could try to reconstruct the genome of each individual created kind, that would be a cool thing to do. It might be something you might look into doing.
Awesome. And we are kind of doing that. So actually in the next debate, we'll touch on that because there's so many things to talk about. Thank you to the audience. We've had a great chat. We've had between 60 and 70 the whole time when I looked into it. Lots of great super chats. I appreciate the support, everybody. Great questions. I'm glad that we can get through most of them. It was a good Q&A. And I guess we'll see you guys tomorrow. We have CJ Cox debating Dr. Kenny Rhodes from Reasons to Believe, I believe. On does the Bible teach a young earth or older? So we'll see you guys then. For now, we'll see you at Praises channel, and God bless. SFT's out.
If you like this type of content, be sure to hit subscribe and also smash that like button. It actually does help.
And I hope you all enjoyed this video. Goodbye, everybody. SFT is out.